Welcome back, everyone. Back to day 4 of our completely free Azure Solution Architect Expert Training, our free Azure training, and our AZ05 3 course. And this Azure Solution Architect Expert Training, we're going to prepare you for the AZ305 exam. This is considered Microsoft Solution Architect Training, and we're covering Azure certifications in today's boot camp. Again, this is free Azure training. It's a free Azure course, and it's provided to you from Go Cloud Architects and Go Cloud Careers. If you don't know me, my name is Michael Gibbs, and I'm the founder and CEO of Go Cloud Careers, and I've been in this tech industry for a long time. I first started working with the cloud in 1996, back when it was frame relay. Got to play with the cloud in when it was then ATM, and then BGP, and then the next cloud was VPLS. This whole cloud computing world has been fun for decades for me, and I absolutely love it. And that's why we're here, to help you guys all get cloud hired. A couple things that I want to tell you about before we begin, while we wait for some people to join us. Going to be a really, really special day. And in that chat box, if you can give me a hashtag Azure Solution Architect Expert Training, I'm going to know that you are awake, alert, and oriented, because I want to know that you're here, you're learning, and you're going to have a great experience today. Some things that I do want to tell you. One is that right now we have a 30% off coupon off of everything using coupon code potential. And if there's any kind of training, if you're looking to get your first cloud architect job, your first cloud engineer job, use the coupon code potential. It is good until Sunday. That is the last time I'm going to talk about business for us, but I'm telling you, if you want to get cloud hard, now you know about it. I also want to let you know to sign up for the subnetting and BGP workshops. This is critical training for the cloud architect job, solution architect job, cloud engineer job. And why do I do all of this? Why do I do all this stuff? And you'll tell you in a minute, I'll tell you exactly how committed I am to you, and you'll see it. It's to get you guys cloud hired. It's all about getting you guys cloud hired. That's why I do everything that I do. It's about getting you guys cloud hired. Now, in these sessions, we're talking concepts. And why are we talking concepts? Because you all have to go in an interview, and they're going to ask you concepts, not how to do stuff. But I still want you to get some hands-on experience. So please download the free Azure Labs, and in your own, go to the Azure Cloud and watch our team demonstrate how to do things, and go do it. Get your hands-on experience at the same time. Do it the free Azure Labs. Go download them. They're not really a download. You'll sign up, and they're in my content delivery system. I like to call it a download, but sign up and do the free labs. Next Thursday, join us on our completely free How to Get Your First Cloud Architect Job webinar. I will tell you everything that you needed to know. And if you want to be a cloud engineer, I'll tell you that too. We will tell you how to leverage your life experience, exactly what the hiring manager is looking for, how to get past HR and get your resume directly in the hand of the hiring manager, the things that need to be on your resume, and everything we can to help you build your best cloud computing career. Now, I'm going to give you a schedule change, and I'll tell you why in a minute. We are going to move the Saturday class tomorrow until Monday. I've had my staff completely clear out my calendar on Monday so that I can hold the next free Azure Solution Architect Expert Training, and we're going to do it on Monday instead of Saturday. And I'm going to tell you why right now. And I'm also going to talk about commitment. Many of you guys ask me, what should you do? I ask this question all the time. They're like, and people say, this is what I've done in the past. What should I do? And I tell people always, doesn't matter what you've done in your past. What do you desire to do? Now, there's a reason I'm going to tell you this. I always ask people, what do you desire to do? Because if you do what you love, you're not working at all. It's just fun. It's just pleasure. So do what you love. I want to show you how important that is. I love teaching, and I love all of you in the cloud community. Many of my students are here, but many of their free students are here as well, and I love you all. Do you want to know how much? During this free boot camp, I have been home with COVID-19 the entire time with 103 fever. And still, I'm here with you all day, every day, because I want you guys all getting cloud hired. No, I'm not joking. I've had a fever and I've been sweating all week. I went through 2 COVID exams yesterday just to make sure, and they were both COVID positive. But this is because I love you, and I want you all getting cloud hired. And when you make your dream your job, and I love teaching people, it's never work. So do what you love, and I want you all getting cloud hired. That's why I do it. It's all to get you cloud hired. So please, if you have a chance to take all of whatever this free training is and make a social media post and give it to somebody else so we can help them build their best career. I've got my staff of 6 people. Pretty much we prioritized free training over sales calls. And the reason we're doing it is we want to make sure that all of you, those that can afford training or not training, have everything that you need to build your best career. So we're out here to try and help you. So please, go out there and share the free so that other people can do better. If for some reason we were going to take a 3 to 5 minute break today, and I asked Chris to put on a commercial, now you know why. And that's why we're going to remove Saturday's training until Monday. I had my staff clear my calendar to make sure that I can give you great training on Monday. But I got to say the COVID's gotten me a little beaten up. So I'm going to try and just rest tomorrow. So I'll see you guys back all on Monday. And we're going to have a great day today, a great class, because we've got to make sure all of you get cloud hired. I want you to get cloud hired. There's nothing else that lives in my life other than getting people cloud hired. I know Chris is working on getting people cloud hired. I know Alonzo's working on getting people cloud hired. I know Chow is still out there trying to get everybody cloud hired. I know Leo's out there working hard to get people cloud hired. And Eddie over there in Cameroon, he's working on it too. So make your vacation your vocation, and you're never working. And then when you have 103 fever and you got COVID, you're still out there teaching people and you're doing what you love. And that way, you'll always be better. So I'll be getting plenty of rest this weekend, but let's get you all cloud hired, everybody. Let's get you all cloud hired. So today we're going to talk about one of my favorite concepts. We're going to begin with one of my favorite things. It's called VNet peering or VPC peering. Why do I love it? Well, kind of just like BGP peering, which is kind of, where I built my career. But what is it? So remember I told you that a VNet is kind of like a virtual private data center. So VNet peering is a way just to connect your virtual private data center to another virtual private data center. That's really it is. So what'll happen is we've all got our virtual private cloud, which is our data center. Some businesses will have many of them. Some businesses will have 1,000 of these virtual private clouds or VNets. And I'm not joking. We could talk about why later. But some organizations will have multiple ones. Or let's think about it this way. If Cindy the Cat LLC makes cat calendars and Chris's cat Sunny the Cat LLC makes greeting cards, if the two of them together each have their own business and they always have their own VNet on their cloud provider, and they wanted to talk to each other, well, they could do it a couple of different ways. They could buy a private line between their organizations and exchange information. And guess what? It would work perfectly. What's that like? What we've done for the last 50 years. No big deal. What else could they do? They take their data center or VNet, which is the same thing, and somebody else's data center and VNet, and they could create an IPsec tunnel between them across the internet. Again, they could do that. But if Sunny the Cat over here is on in one VNet on Azure, and Cindy the Cat over here is on another VNet on Azure, all they've got to do is connect to each other on the Azure network. So high-speed Azure network, high-security Azure network, that's called VNet peering. VPC peering, whatever you want to call it per cloud. AWS calls it VPC peering. I think Google calls it VPC peering. I haven't set anything up in Google in a while, but it's the same concept, only the names change. So we're peering across the Azure network. And why are we doing it? We're leveraging the Azure network as our word or a network. So because it is a private network, not a public network like the internet, it's going to be relatively high bandwidth and relatively low latency because we can guarantee the performance as network engineers and architects in our network, but I can't guarantee it on somebody else's network like the internet. So this makes it very easy for resources in our one VNet to talk to each other. And when we're dealing with this, we're supporting like two kinds of peering: virtual network peering and global network peering. Let's talk about what those are. Virtual network peering is connecting two VNets or two virtual data centers in the same Azure region. Remember, region's a big geographic area. Availability zones are basically a data center. So inside of the major geographic area is virtual network peering. Now, what then would be global virtual network peering? Well, if virtual network peering is in the same region, global virtual network peering is across regions. No big deal. They make it sound so complicated with all these names. Virtual network peering, same region. Global virtual network peering, in between regions. No, let's not make it so complicated. So what's this all look like architecturally when you see it? It kind of looks like this. So you can see we've got VNet A. Now this is Cindy the cat. And on VNet B, we've got Chris's beautiful cat, Sunny. It's like an orange Maine Coon. And they're VNet peering together across the thing. So kind of keep that in the back of your mind. That's the Azure VNet peering. And we're doing it all across. Now, obviously, you can see they need to be on different IP addresses that they're going to communicate to each other. That's it. That's VNet peering. People make life complicated. It doesn't need to be. All right. So remember this. VNet peering is non-transitive. I'll explain what that means. So when we're dealing with VNet peering architectures, we get into these problems that either hub and spoke and fully meshed. Now, I just told you, VNet peering is not transitive. So if any of you guys or girls that are out there have ever worked on IBGP or interior BGP, you may have dealt with the fact that IBGP is not transitive. Meaning, if I've got three routers, my head being a router, depending upon which country, and each hand being a router. What non-transitive means, if this over here is A, my head is B, and this hand is C, if A tells B about its routes, and then C learns about this, and C tells B about its route, and A learns about it, they can all talk to each other. It's really great. But if A tells B about its routes, and B doesn't tell C, and if C tells B about its routes, and it doesn't tell A, then A and C don't know how to reach each other. And that's what non-transitive routing is. So in BGP, guess what? We had this really cool workaround to that rule, and it was called a route reflector, which we'll get to. Or else we fully meshed our peers. So let's talk about what that actually means and why fully meshed can be a problem. So the mathematical formula of VNet peering or IBGP peering to determine how many peers you need is as follows. N times N minus 1 divided by 2. I hate math, but let's think about what that means. It means if we've got three things that need to peer, we have 3 times 3 minus 1, which is 2. So 3 times 2 equals 6, divided by 2 equals 3 sessions. No big deal, right? Nothing. Now, 10 times 10 minus 1, which is 9. 90 divided by 2 is 45. So we go from 3 peering sessions when we have 3 of them to 45 when we have 10 of them. Now do 100 times 99 divided by 2. Whoa, you're dealing with peering sessions everywhere, and the scalability of this is ugly, ugly, ugly. And trust me, any of the network architects that have dealt with this stuff for years do not like it at all. So let's look at what this looks like. I'll show you fully meshed. This is a fully meshed environment over here. Everybody connects to everybody. So this way, if this person tells this person, and this person tells this person, and this person tells this person, and this one connects this way, and this one connects this way, everybody can reach everybody. And nobody's telling everybody because it's like this. Subnet A is Chris. Chris tells subnet on the right side, Alonzo. Now, Chris is also telling Mike and Chow. And that way, all of us know because Chris told us directly with the peering, and that's what's going on with this. Now, when we get into other solutions, there is a way we can make this work. And IBGP works the same way. So we're dealing with, when we deal with the next thing, we're going to deal with an IBGP situation. I'm going to explain to you how things work. Regardless of what the names are, if you understand things, it becomes easy. So over here in this particular situation, let's say over here, actually, I'm going to use a square, even though it probably should be a circle. Let's say this is BGP, because whether it's BGP, which we're dealing with now, or whether the BGP is something else, it really doesn't matter. But let's just pretend right now it's IBGP peering session. And in this particular situation, let's assume we've got 3 sites. Now, in a hub and spoke environment, and this is what the hub and spoke environment looks like, with IBGP, we have a problem. And here is the problem. So let's say over here, I'm going to call this, let's put the letter A to make it easy. Here's the letter B, make it easy. And here's the letter C. So in a hub and spoke environment with normal non-transitive routing, like OSPF or EIGRP or intermediate systems to intermediate systems, when we're dealing with this, let's see what actually happens. What actually happens is as follows. Normally speaking, A will tell this central site its routes, which will be propagated to B and C. C will tell the central sites about its routes, and that's why everybody can talk to each other. But with IBGP, there's a rule that says as follows. A can tell B, A can tell the center, but the center can't tell B, and the center can't tell C. So that's what enables non-transitive routing. If you don't know how to read something, you can't reach it. Remember yesterday we talked about not being able to swim to England, but if I had a plane or a boat or a route I could get there, well, it's the same thing. So when we start dealing with VPC peering in AWS, and we get into things like Transit Gateway or Cloud Hub, or we deal with the BGP environment, or we're dealing with Azure VNet peering in a hub and spoke environment, I want to let you know what's really going on. Basically, this thing in the center becomes what's called the BGP route reflector. And what that means is, regardless of what's being told is as follows. It breaks the rules of non-transitive routing, which says A can tell the route reflector, who's now allowed to tell B and C can tell the route reflector, who's now that. So what we end up doing with this route reflector concept, regardless of whatever we talk about, when we talk about hub and spoke environments in the Azure cloud, on the AWS cloud, on the Google cloud, we're really dealing with BGP route reflectors. So if you want to know where this does come from, 30, 40-year-old networking technology. So that's where this stuff comes from. So now if I show you a hub and spoke peering environment, which you're seeing here in an Azure environment, it's going to actually let the information flow in between environments. So let's talk about an Azure hub and spoke design. It uses something called VNet Hub or Virtual WAN, Cloud Hub, Transit Gateway, not the same thing. BGP route reflector. Let's call a spade, not make anything too complicated. So the VNet Hub supports communication to centralized policy and shared resources. Virtual WAN, by comparison, is as follows. It's for large-scale branch-to-branch and branch-to-Azure communication. What does this all mean? It enables us to build this kind of hub and spoke design, where we can create a hub, and then we can allow routing in between spoke sites. By the way, hub and spoke is the normal network topology, but lots of you guys and girls are familiar with it. Have you ever gotten onto an airplane? They run, generally speaking, a hub and spoke network too. I live in Palm Beach, Florida, or right near there. So here's what happens. I want to go anywhere. I jump on a plane for Delta, and I go straight to Atlanta. And from Atlanta, which is the hub, I can fly to Greece, I can fly to London, I can fly to all kinds of cool places from Atlanta. But in Florida, I can only go to New York, Atlanta, Dallas, Houston, Cincinnati, I think Salt Lake City, and 1 or 2 other major hubs. And then once I connect to one of these other major hub cities like JFK, I can go anywhere. So that's a hub and spoke design. You're all familiar with it, but that's why I like to say, make your life experience work experience. It's really the same thing. It's just a matter when you use it. So what can we really do here? We can create a hub on one side, a hub on another side, and then they compare with each other. So we can create this beautiful WAN, or wide area network, on these cloud providers by leveraging their network. And imagine if this was extranet partners by comparison. Let's say over here, let's pretend that we are an auto parts manufacturer. I mean, we make cars. Spoke 1 could be tire company. Spoke 2 could be a different tire company. This Spoke 40 could be an oil company. Spoke 4 could be a metal company. Spoke 5 could be a windshield company. I don't really know what goes into cars. I don't know much about cars at all. In fact, I just know how to drive them. I don't know how to use a screwdriver, a hammer, a nail, or anything. I really always wanted to, but I'm a specialist. I know my skill really well, and I don't know how to do anything else in the world. But, that's just me. So what is a hub and spoke design? It's a networking model for efficiency and communication. Because, look at it this way. If you connect lots of things in Atlanta, they only have to connect to Atlanta. Now, of course, would Atlanta be a single point of failure? The answer is yeah. So you need multiple hubs and multiple spokes, and then they need connectivity to each other. Otherwise, you don't have a high availability system. So let's go through it. So what is VNet Hub? VNet Hub is a central plane of connectivity to connect to anything, like your on-premise network, etc. It's a place to enable your hub and spoke services. Let's talk a little bit more about the virtual WAN. So it enables branch connectivity via the virtual WAN to partner devices. And that partner device can be anything. It can either be, software-defined networking, which is really where we're coming in the future, etc. And a VPN, where a VPN could be connecting to a VPN. It also enables something like site-to-site. So site-to-site VPNs are two different cases, no big deal. Remote user, we could technically set it up as the following. We could have thousands of users, and they could connect to the center, and that could be a hub and spoke design as well. We can set up between our hub and spokes private lines, otherwise known as express route. I don't know how they can make up these terms, but somebody in the marketing department did. We could do intra-cloud connectivity if we wanted. So connect to AWS, Google, etc. if we wanted to set that up that way. And we can use routing or the Azure firewall, etc. for encryption between our systems and security protection. So effectively, the virtual WAN is doing the following. It's enabling the company to use the Azure cloud as a wire, a pseudo wire, like you're getting a virtual Ethernet connection, even though it's not. And the point is, now that you can use SDN and private lines and any kind of IPsec tunnel and even SSL-based VPNs, like with OpenVPN, you've got lots of connectivity opportunities. Why do I like it? What's one of the coolest things about the cloud? It's pre-built, right? So what is the most complicated part of everybody's system? The most complicated part? The network. It's 10 times more complicated than anything. And if the organization is not managing their network and all they have to do is create connections, it's just so much easier. So they can get away with much less networking staff, much to the dismay of people like me. That's why we network architects all became cloud architects. No, we just moved on to different roles. We evolve with the time, otherwise we become dinosaurs. I still love my hardcore networking though. So let's talk about a little bit more about the Azure Hub and Spoke design. Actually, I think we covered that. So now let's talk about Azure Peer Transitive Routing. As I showed you before, what that's really enabling you to use is create this hub and spoke topology where systems in Azure actually, can use the organization. The Azure network is the private realm. So when we're setting this up, we've got two kinds of peering. We've got something called virtual network peering and global virtual network peering. I think we actually talked about this before. But I'll say it one more time. Virtual network peering is inside the same region, and global network peering is in between regions. So why are we doing this? It's the ability to use the Azure network as the WAN. So let's walk through some more photos of what it actually looks like. Peer-to-peer transitive routing. Here we've got the hub of the network, which is basically being configured as a route reflector, right? Even though you don't see what's going on under the hood. And this enables this system, and this system to all reach each other through the peer. Now, because we can actually connect our on-premise or other organizations either via the private line, which is called ExpressRoute in Azure, or a VPN, we can build an entire WAN all on the cloud, which is really simple and elegant. Okay, so we're going to get to the content delivery networks, but let's make sure, see if any of you guys have any questions. So I want to make sure we give you questions. I want this to be a really great learning experience for you. Please, I'm going to say this is conceptual training, but we do have hands-on training. Please, register for the free hands-on training and walk through the hands-on labs. Let's see if you guys have any questions. Can you, Carl, if a business migrated to multi-cloud, where would they get their data on-premise data center to the virtual? Okay, I'm trying to see if I can understand this. I can't, I'm going to try and read that a second time, Chris, and see if I can figure it out. Pushing you back to, if a business migrated to multi-cloud, would they get their on-premise data center so that their different virtual cloud could be connected in the way they wanted them to? I still don't understand the question, but
they said keep, not get. That's what. So read it again, but read it with keep instead of get.
If a business migrated to multi-cloud, would they keep their on-premise data center so their virtual cloud could be connected in case they wanted them to? Kenya, it's totally dependent upon the business. If the business wanted a hybrid cloud, multi-cloud, then they would keep their on-premise data center. If the business just wanted to use two clouds, then they would get rid of their data center. 100% based upon the business requirements. If it's really a mission-critical business that needs high performance, low latency, they should keep their data center because you can do much better performance in the data center locally than you ever could in the cloud. And that way they could keep their low latency critical compute in the data center and then connect to two clouds. That would give them better performance, better availability, better scalability, and leverage the best the cloud has to offer. But if the performance of the cloud is good enough, it might be cheaper just to maintain two clouds. So the real question is, what are the business requirements? It all comes down to that. If it's a hospital, I'd make sure they have a local data center, because if the WAN went down and they were in a single cloud and the medical systems were there, somebody could die. Put them on two clouds and it gets much better. But if something happened to global internet routing or the internet service providers that are providing the WAN, if it's local, you're there. So it's all based on the business. Eugene, can I explain how hub and spoke differs from spine and leaf? Yeah, sure. In principle, they're the same thing, but spine and leaf, which I have never used, Eugene, it's also called the collapsed core, and there's lots of good reasons not to use that. The concept was this: we had a core of the network, and then we have access systems that were plugged into the network. And that way you get your core routing, which was very important in your data center, and your leafs were where you'd plug your servers into. Now, the problem with that is, when you use just spine and leaf like that, we've got a core and then you've got an access layer. When stuff happens in the access layer, your core falls apart. So for organizations that need really mission critical systems, they do what's called the core. And in the core, this is where you have your high performance router. This is more CCDE level, CCIE level, none of the stuff they would teach at the CCNA, which is just that spine and leaf. And in the core of our system, we've got our big, powerful, strong routers. And then we have what's called the distribution layer, and that connects to our core. And then we have the access layer, which is where our servers plug in. So it's a layer of decoupling that's not in the spinal leaf. And by doing this, if something happens to where the servers are, where they plug in, and the users plug in, it gets caught into distribution layer and not sent to the core. So when it really matters, we actually use a core extra and distribution layer, which is a 3-layer network architecture. The concept of the spine and leaf is kind of more the CCNA level, junior level networking, where in the center of the network, we've got our big switches, our big routers, and at the edges, we've got our small switches that we plug into. So that's the spine and leaf. Now, it looks a lot like what we're talking about here, but it's actually not, even though it looks that way. What we're talking about in the spine and leaf is inside of your campus, for the most part, big powerful switches, distribution layer, and then your access layer. But it's very similar and could be construed the same way. But typically speaking, really important networks are architected with a 3-layer or 3-tier core access distribution. The more you can decouple your systems, the less likely they are to break. And trust me, everything breaks. Everything breaks. Everything breaks. You didn't hear what I said about global network peering. Apologies about the voice. Like I said, I'm kind of home with COVID, so I'm not 100% all me right now. But I'll do the best I can, and I'll do it a second time. So what did I say about global VNet peering? It's across regions. That's all I said. That's the difference between the regular VNet peering and the global VNet peering, is whether you're across regions or not. Great question. Is there a cost of using the Azure network? There sure is. There sure is. And that's what's different about using cloud providers versus regular networks. So here's the thing. In a normal network, I decide to get there's a really nice soul warrior. His name is Hand of God. His name is here. That's his handle. He's in London. And normally speaking, I would buy a link to him. And I buy a 10 gig link. And if I want to send him data, I can send him 1 gig, 10 gig, and doesn't cost me anything different at all. I just pay for the link. Now, when we're connecting to the cloud or use the cloud network, they charge us for the link, then they charge us a daily fee to have the link, and then they actually charge us to use it. So when we're dealing with cloud providers, they charge us to use their network. And it's not cheap, but it's generally cheaper than it is to build your own network, buy your own things, your own router switches, and maintain them. And here's the thing. As a rule, everything in the cloud costs far more than it would cost you to build it on your own. But here's the big but. The operating cost to manage these things, the people you need, all those ongoing expenses, as a rule, are cheaper on the cloud than they actually are in the data center. Because it costs a fortune to hire the right people that can build the right network, the right security people to do it. Now, when you have them, the magic that can be done. So yeah, there's a cost of using it. Absolutely. But it's still typically cheaper than buying all the routers and all the locations and having the people to set up all the routers and the WAN locations, et cetera, et cetera, et cetera. Eugene, yes, basically 2-tier versus 3-tier, but hub and spoke is used as a WAN model as a rule, and spine and leaf is typically used as a LAN model inside of a campus. But this concept is the same. Not always used that way, but generally speaking. Miguel, good. I do want you feeling confident. And I'm glad you're starting to understand the pieces and parts and concepts. And you've been coming around for a little while. And like you see, it shouldn't matter whether we're talking about Google, Azure, or AWS. If you guys all can give me a hashtag Azure Solution Architect Expert Training. And while we're at it, I'll answer one more, Chris, but to please, if you can give me a hashtag Azure Solution Architect Expert Training in the chat box. To confirm, ExpressRoute is a private line to the Azure network, meaning it's the equivalent of a direct connect on AWS, or I think a direct interconnect on Google. I think that's what they call it. It's really just a private line. And it is a purely an Azure made up name. The rest of us would call it an Ethernet private line. Hi, Pawan. I'm loving Ashwini, Azure Solution Architect Expert Training. Mr. Gee, Azure Solution Architect Expert Training. Joe, good, Azure Solution Architect Expert Training. Alonzo, Azure Solution Architect Expert Training. Leonardo, Azure Solution Architect. I don't want to get your name wrong. Jamal, Azure Solution Architect Training. And Tracy, Azure Solution Architect Training. Loving this. Loving this. Loving this. Ron Miller, Azure Solution Architect Expert Training, and IT Pro. Thank you, Azure Solution Architect Training. McBee, Azure Solution Architect Expert Training, and Mike Chow, Azure Solution Architect Training. So happy to see you guys. I can see we have Io, good to see you. Miguel, good to see you. Rohan, Azure Solution Architect Training. Yes, yes, yes. Hit that like button, and if you haven't subscribed, please subscribe. Tell a friend to watch our free training so we can get lots and lots of people hired. AJ, hoorah, and thank you for that blue wrench. I'm very grateful. Okay, so we're going to start talking about the Azure Content Delivery Network. So let's talk about the Azure Content Delivery Network. What is it? It's a content delivery network. So what does it do? Content delivery networks are both a network and a bunch of caching servers. Note, network plus caching servers. What do most people only tell you about? The caching servers. What is it? It is a network and a set of caching servers. We need to talk about that, and we will go through these as we go through this. Why do organizations use it? Content delivery networks offload the web servers dramatically so it scales better. Content delivery networks can make sure that only legitimate web requests actually go to the web servers, hence preventing DDoS attacks. And content delivery networks get your traffic off of the slow internet onto a private network to reduce the latency to get back to your network, your web server. So again, better, faster, and cheaper. That's why we use content delivery networks. And here's what happens. We'll walk through them. We'll walk through the workflow, and I'll show you how they work, and we'll get to the technology. Here is the way the content delivery networks work. Here's the way the content delivery works. So I got a user. We got a user over here. The user is in a peach-colored shirt. I'm sorry if that's not the right color. I'm not an expert on colors. With a blue tie. The user with the peach-colored shirt wants to go to www.gocloudcareers.com because he wants to get cloud hard and get his first cloud architect job. So he goes to www.gocloudcareers.com. And when he puts that on his browser, the first thing that happens is he does a DNS lookup. And he gets redirected to the point of presence, which is the content delivery network location. And as soon as his request hits the content delivery network location, here's what happens. The first thing that happens is as follows. First, his request goes to the content delivery network. And the question is, do you have the web page, www.gocloudcareers.com cached? And if it does, it sends me the information right away. But if it doesn't, here's what it does. It goes to the source of the regional cache and gets it. Now, it doesn't ride the public slow internet when it gets it. It goes straight to the source on the content delivery network, private network. Then it gets sent back to the cache, and then it gets sent back to the user. Now, 5 minutes later, his twin brother, who looks identical. Actually, let's do this. Let's change users. Now, 5 minutes later, this person, the guy in the blue shirt with the orange tie, decides to go to www.gocloudcareers.com because he wants to get cloud hired. So what's he do? He goes and he hits the point of presence. And when he hits the point of presence says, I have the web page for you. And it sends it back directly to me. Now, I'm done. And I get my website real quick. And now a few minutes later, The woman over here decides that she wants to get cloud hired and she's going to go to www.gocloudcareers.com. So what does she do? She goes, she hits that cache. Wow, it's there and it gets sent back to her. So as you can see, the web servers or our object storage responded only one time. The rest of the times, the cache did it. So you can see that we offloaded our web servers. And you can see by taking the traffic off of the internet, we got it there quicker. And if it's already stored at the cache in the person's geographic region, guess what? She got it quicker. Want to know more? When our traffic changes in between regions and geographies in the cloud, they charge us. So the less traffic we have going on, by far the better we're going to be. So kind of keep that in the back of your mind. That's why we're doing these kinds of things. So we're going to talk about a lot of options with the Azure Content Delivery Network. They have a serious content delivery network. I mean, seriously, it's good stuff, high-end stuff, and there's lots of options. So, and we'll talk about them through, and I'll get a little geeky on some of these because I love content delivery networks for that reason. They promote scalability and security. Whoa, and save money. Better performance, scalability, security, and it saves money. That sounds like something that you just have to have in every architecture. Pretty much you will. So let's talk about the Azure Content Delivery Network. It needs a minimum of a subscription. Well, yeah, you're going to use the Azure Cloud. You need an account. You need to create at least one CDN profile, which is basically a collection of content delivery network endpoints. And we can use multiple profiles for organizing our content delivery endpoints, either by internet domain, web application, or other criteria. And we can create multiple profiles across different pricing tiers, which offer us different things. So what are some of the benefits? Better performance, improved user experience, less latency. Less latency means better ranking in Google, huh? Kind of important, huh? Better scaling, and we can distribute our user requests off, and we can serve content from the edge of the network with less latency. Now, the Azure Content Delivery Network is going to have all kinds of features. Like I said, this is a robust content delivery network. It gives us geo-filtering, HTTPS custom domain support, dynamic site acceleration, file compression. Ooh, think about that. While you're riding on the private network, you take a file and it's being compressed to take less bandwidth to get to you faster. Good stuff. Diagnostics, logs, and CDN caching rules. That's our standard Azure Content Delivery Network. So let's talk about geo-filtering. What is it? Geo-filtering is the following. Geo-filtering is the ability to restrict your Azure CDN by content to a country or a region. It lets you create rules on specific paths of the content delivery network to set rules by, like, say, blocking content. Like, for example, in some regions, some content is illegal. For example, when I worked in Dubai, everybody had to go through a proxy server. They wanted to make sure that nobody, was getting anything that was deemed illicit content. Now, illicit content is different per country, but whatever the plan is, you can filter it to be culturally relative and abide by the laws and rules of the place, which is really good. It enables HTTPS custom domain support, which means it'll make sure your sensitive data is encrypted. You can identify who the user is, the endpoints, et cetera, et cetera. So that's always a good thing for both when we're dealing with any kind of web application. Let's talk about dynamic site acceleration, which is pretty cool. It optimizes performance and latency of unique content. It uses the Azure REST APIs, Azure Portal, and any of the client software development kits. You can set this up. You can do it through route optimization, TCP optimizations. It does some object prefetching. Pretty cool if you're using Akamai's content delivery network. And that's the thing with Azure CDN. They're not going to say, hey, we're Microsoft, we got the best. They're going to say, hey, we're Microsoft, we got a great one. Oh, by the way, we work with Akamai, which is one of the best content delivery providers in the world. And we can offer you through their network, the Verizon network, because we want to partner with the world's best to bring you the best. So Azure does things a little differently, and I love that about them. And can do image compressions, again, when you're using Akamai, because Akamai is the market leader in content delivery networks. So Azure is saying, hey, wait, you can use ours, or you can use the best, and we're willing to work with you, or one of the best. Love that. Let's talk about file compression. Half of what's going on is we're riding the network. And depending upon the bandwidth of the network will determine how long it takes you to get the content. I got a picture of Sunny the cat, Chris's beautiful orange Maine Coon. Beautiful cat, by the way. And I want to send it to Abigail over there because she loves cats too. If the network bandwidth is slow and it's a big photo, it's not good. But if I can squish that photo down by using a compression algorithm on the wire, it's like I can speed up the WAN. And many years ago, I worked with this tech that what it would do was would compress the WAN. And that way, when you only had a T1, which was more like 1.54 megabit per second, yes, that was a fast line when I started working, we could get that up to 4 or 5 or 6 megabit per second through compression of what we can actually push through the network. So file compression is awesome. And there's two options for file compression we can use. We can have the content delivery network pass along the compressed files to deliver them to the clients, or the CDN can compress the files and serve them to the end users if they're not compressed by the original server. So lots of ways to really help throughput and performance. Now, when you're using a content delivery network, ideally you've got some labs, right? And logs, so we've got Azure Diagnostic Logs. They're optimized to view and save any kind of core analytics into one or more destinations, including you can send it to your Azure storage account, you can send it to the Logs Analytics Workplace, or you can send it to the Azure Event Hub. Let's talk a little more about logs, and more logs, about the Azure Diagnostic Logs. They allow for the exporting of basic usage metrics from the CDN, telling you know what it's gone, types of data that you can export. You can export data to blob storage, CSV, or generate graphs in Excel. You can export data to event hubs, and you can even correlate that data with other Azure services. And you can export data to Azure Monitor Logs and view that data within the log of the Analytics Workspace. Let's talk about some of the CDN caching rules. Why are you doing these? We want to make sure that we can ensure that our sensitive data is delivered via SSL or TLS, because we don't want to send sensitive data over plain text ever. We want to make sure that when a web browser is connected to HTTPS, the browser is actually going to validate the website certificate, as we always should. You know, when you go to a website and it says don't trust because the certificate is not valid, that's what's going on. So let's talk about two options for controlling how the files are cached. You can use caching rules or query string caching. So the two options for controlling how files are cached, let's talk about caching rules. Basically, we set one global rule for each endpoint. And at that point, it'll affect all requests to the endpoint. The global caching rule will override any HTTP cache directive headers if we set them. By comparison, let's talk about the query string caching. Users can set one or more custom caching rules for each endpoint. Once we set the custom caching rules, they must match specific paths, and file extensions and rails are going to be processed in order. So when it comes down to it, you have four options for the Azure Content Delivery Network. We have standard from Microsoft. That's basically the Microsoft Content Delivery Network. We've got standard from Akamai, basically an Akamai Content Delivery Network. Standard from Verizon and premium from Verizon. So we'll talk a little about these things. I'm going to more show you here because, you know, there's a lot of stuff and I don't want to dwell on these slides forever. This is your basic content delivery network from Microsoft. Your dynamic site acceleration, and that's coming from the Azure Front Door service. It gives you good streaming. It works on any kind of TCP port that you're dealing with. It works with your global load balancing services, IPv6, IPv4, HTTP2, read-write. So you're dealing with, for the most part over here, standard, normal content delivery network features and functionality. Now you get some pretty good security with it as well, specifically the HTTPS, the geo-filtering, your token authentication, your DDoS protection, bring your own certificate. So good standard security stuff. I mean, it's a good content delivery network. You get plenty of analytics and reporting. Now let's talk about when it starts to get better. So now let's talk about standard from Akamai. We're still getting the same, but now we're getting adaptive image compression to make our WAN operate faster. Now we're getting large file optimization, big stuff. We're going to squish it down, make it send faster. We're starting to see you're getting a little more here. You're getting into more industrial content delivery networks. And you can see you still have custom domain, but you can use a CNAME to map, the ugly domains that I showed you and talked about yesterday to your nice content, to your content delivery network, so your users get a user-friendly name. You get great logs with it. And here you're getting much more integration into APIs, for example, and much better compression and compression encoding. So, we're getting into some very robust content delivery networks with this standard from Akamai. Look at standard from Verizon. The standard, so dynamic site acceleration, all TCP parts. Asset preloading, what's that? That's pretty cool. Asset preloading enables you to tell the remote sites, here's your stuff ahead of time. Push it, and then it's basically local. So, that's getting pretty cool, which we like. As you can see here, you've got some good DDoS protection, your CNAMEs to come up with mapping one domain to another. So this is a pretty robust platform. Good diagnostic log, good reporting. And again, plenty of integrations that you can do and lots of compression encodings to really make sure your data gets there. So this is, again, another robust content delivery network. Now let's talk about, really maxing out and pushing the content delivery network to the nth degree. And this is premium from Verizon. And this is pretty robust. So you're getting optimization of your video delivery, lots of global load balancing, fast purge, get rid of stuff in the cache, preload it in your remote sites, lots of rules. I mean, this is a very robust content delivery network. Plenty of security, as you can see. Lots of analytics. With this, you know what's going on, how it's going on, why it's going on, and you can make better predictions for the future. So this is serious, serious stuff. And of course, it's quite easy to use, etc., etc. So, I mean, lots of compression algorithms, and realistically speaking, we're dealing with some serious power here. So I love that. Microsoft says, here's our main offering, our cookie cutter solution for you. Need something bigger? Guess what? We've got these options for you. Why do I love that? It's not like the cloud providers on their own saying, hey, we've done it all, we're experts. They're saying, we've got a great solution for you, but if you need something that's a little more, here, we've partnered up with the best and the brightest in the world to help get it for you. That's all I could ever want. Excellent. So let's talk about Azure Front Door. This is a critical component of Microsoft's content delivery network. What does it do? Front Door caches that delivers the content to the edge caches in every single location. And, there's hundreds of these global points of presence throughout the world. Chances are, it is sitting near you. They've got a local point of presence, which is going to make everything perform as if you're there. And if it's not that far away, which we absolutely love. Let's talk about Azure Network Watcher. You got to know what's going on in your systems, right? So if any of you have ever worked with Cisco NetFlow, or you can see what kind of traffic's going through your network. If any of you have ever worked with AWS VPC flow logs, it shows you what's going on through your network. So what's Azure Network Watcher? The same thing. Cisco NetFlow from 25 years ago is Azure Network Watcher now, or AWS VPC flow logs now. Same concept. And it's a service that basically incorporates monitoring tools for diagnostics, viewing metrics, and enabling and disabling logging resources for your VNet. So what does it do? It shows you what's going on in your network. And it enables you to see your traffic flows, etc., etc., etc. Between your virtual machines. You'll be able to look at your load balancers. You'll be able to see what's going to what. Do you have a firewall rule that's kind of bad, etc.? So you're using Azure Network Watcher for monitoring. Communication between a virtual machine and an endpoint. kind of like you can use it almost with a protocol, like a protocol analyzer. So if any of you ever ran around with a sniffer or a protocol analyzer, where what you were doing is you were trying to like look at the packets that were traversing a network to try and see this was being blocked by a firewall, et cetera, that's what we're kind of talking about. Keep that in the back of your mind. Diagnostic purpose. Here's what's you're typically going to go on. You're going to find packets that are accepted and rejected when they're not getting to the destination. And it's usually going to be a firewall rule, a network security group kind of thing. You've made some little error somewhere, and you're going to be able to catch it here. It's going to be very helpful in diagnosing things. So, diagnosing network traffic filtering problems to and from a virtual machine, routing problems to and from a virtual machine, outbound connections from a virtual machine to the internet. You capture packets on the way to a VM, just like a sniffer. There's lots of sniffers. Now you can even get cheap ones that are like free, like Wireshark. When I started, sniffers or protocol analyzers were real expensive, and there was no way you were getting one for free. I mean, they're like $5,000 just for the software to stick on your notebook. Times have changed quite a lot. Azure Network Watcher can give you some metrics. So you'll be able to figure the number of resources, for example, and if your limits are met within your subscription, then you know what to do, or how to do about it, reaching out to support, et cetera, et cetera. You also get some logs. The logs will allow, and you will get to see, what's been allowed and denied. We'll be able to analyze the traffic from a network security group to and from one, monitor diagnostic logs for resources, and because we'll be able to look at the flow across these security groups. It's TCP source address, destination address, protocol, port number, et cetera, et cetera, et cetera. Let's discuss this very briefly, and then I'm going to spend a bunch of hours with you. When you're dealing with Azure Express routes, when you're dealing with any kind of routing on the network, we have two choices in the cloud. It's basically speaking static routes, manually configured, or BGP. And Azure supports using BGP. BGP is a path vector exterior gateway protocol that's used for interdomain routing. We use it because it scales so well, and it's highly tunable. Scales so well, what do I mean? Well, if I connect to the internet, I'm going to deal with approximately 800,000 routes per ISP. BGP is designed for that. No other routing protocol. BGP allows a lot of security and tuning where I can basically filter routes. BGP enables traffic engineering. I can easily manually tell it how and where to send my traffic. Multiple internet connections to Azure or multiple private lines? Guess what you need? BGP. And obviously BGP works with autonomous systems number. You get one from your internet service provider, or here you could use whatever they tell you to use. And it works by my autonomous system is this, your autonomous system is this, and we connect each other and we determine what information we exchange. An autonomous system is nothing more than an organization, and each one gets their own number. I'm going to leave this BGP information to next week. I'm going to spend 4 hours setting this up and talking about it with you. Why do I want to do it that way? I want to know that we give you a good understanding of BGP that I can't squish into 10 minutes. So let's talk about that. So that's why we're doing it. Hey, Chris, I believe it's time for me to take some questions. So let me take some questions for a few minutes, and then we can go back and talk. Please join us for this completely free BGP workshop, which is going to be 4 hours next week, and networking workshop, which is going to be another 4 hours next week to help you get the skills you need to get cloud hired. Do you have to size the cache correctly? In general, they scale as you need them. Chris, you can go to the next one. Nick B. CDN can be used to restrict access from a specific country. Can a CDN allow from a specific IP coming from a restricted? If not, okay, so here's the rule. if you have to restrict access to a certain country, you must restrict access to that country. And you're going to be doing it by, as a rule, restricting a site or range. Now, why would you want to be unrestricting a single address from a restricted location? If you did, would that be the right way to do it? Or would it be to create a VPN and completely bypass the proxy or bypass what is actually being used? So the question is the use case and why. So why are you trying to do that, McBee? And what might be the better ways to do that? Good question, though. Hi, Mike. How exactly can content delivery networks prevent DDoS, whether Akamai, Verizon, or Cloudflare, or anyone? That is a great question. And they are part of the solution, Pawan, but not the whole solution. And here's the reason why. So if I were to DDoS a server, I were to either send a ping of death, I would send 15,000 half open TCP connections, et cetera, et cetera. What I'm trying to do is I'm trying to overwhelm the server or group of servers with a bunch of requests. I want it, 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 and I want it. And we're trying to overwhelm the capacity of the servers. Now, if those requests go to the servers are going to be busy with the I want it, I want it, I want it, and can't even fully respond because it's incomplete information. By comparison, if the content delivery network is trained to only allow legitimate requests. So if a bunch of pings of death are being sent, the content delivery network won't forward it. If a bunch of half open or malformed TCP open connections are there, they're not forwarded. So the content delivery network blocks so much of the bad stuff before it even gets there. That's how it helps with it. Again, it's part of firewall, IDS, IPS systems, network security groups, anti-malware protection, what do you call it, DM, proper demilitarized zone design, and so many other things. But that's how they do it. What is the use cases for the CDN? You're trying to get your content to the users faster, to reduce the latency, to reduce the load on your servers, to reduce DDoS. CDNs don't provide object storage. The CDN doesn't care where your content's coming from. It can be coming from your website in your data center. It can be coming from Azure. It can come from Google. Who cares? They provide a network to get your content to you quicker. Most websites are not based upon object storage. Most websites have web servers followed by application servers where the business logic is, followed by database servers. Now we stick on object storage things like software that needs to be distributed or images of things, etc. as a rule. And we can build websites with object storage and we can build websites without object storage. And no matter what, the CDN will be able to access anything. They don't care where it's coming from. So why do we do it? I want to get my content globally. I want to reduce the latency. I want to protect myself from DDoS attacks. That's why we use content delivery networks. Railhan Fernandez, is it accurate to say that CDN includes all the functionalities of WAN Accelerator? Railhan, if you're dealing with the 30-year-old WAN acceleration that we're talking about, that I was talking about, it's very similar. The answer is yes in many ways, but here's the difference. The WAN accelerator was over your private WAN. And basically, it was a compression algorithm you'd run on each side of your routers, where this is an internet accelerator, which is not your WAN, but very similar in those other ways, in terms of functionality, etc. Okay, customers don't keep their content in the CDN. The CDN accelerates our content's distribution. So if I've got a website and a data center that's sitting in my house, I can still connect my house to the content delivery network and they're going to accelerate it to the rest of the world. So it really has nothing to do with the cloud provider at all. CDN and multi-cloud Azure Google. As Azure friendly Verizon CDN, as Google friendly Verizon. Here's the thing: just use Akamai and not worry about it, and use it across everybody's content delivery network. You can use any CD you want. Now, Azure has a really good Verizon CDN service. Excellent. And a really good Akamai service. But you can use any content delivery you want. Just like DNS. I'm not going to use AWS Route 53, and I'm not going to use Azure DNS. They're good DNS services. There's nothing wrong with them. But if I'm going to go multi-cloud, I'm going to use a solution that's going to work if Azure and AWS both were to die. I'm going to stick my DNS servers in Azure AWS in my data center. So, you use multiple content delivery networks if you can. Because tech fails. 2 is 1, 1 is none. So I don't use any cloud proprietary anything whenever I don't need to. For that reason. Angelo. Mike, does Azure CDN support dynamic origin? I'm not completely sure of that one, Angelo, but it's a very good question. But the CDN does definitely offer the good DDoS protection for the origin of whatever it's coming from, like content delivery networks do in general. Miguel, what's a common question that an interviewer would ask on BGP and how to answer it? Oh, I could think of thousands, but I might ask people how to load share across two equal cross paths across different internet service providers without getting out of order packets. I might ask someone how to make sure that one subnet is preferred over another subnet. I might ask them, can you tell me, based upon these 2 routing tables, which route will be chosen? I will ask people about the BGP rib versus the fib. I will say, you've got this route coming in with this prefix, with this weight. You've got this route coming in with this prefix, this weight, and this local preference. Which one is the router going to take? I would say, okay, you've got this environment. You've got this many IBGP pairs, this many EBGP pairs. What are your scalability options? I might ask you when should you use a confederation versus when you should use a route reflector versus when you should fully mesh your peers. I might ask you about, when you aggregate your routes, what might you do and how might you send a summary route in a more specific subnet on something? These are just basic things that I might be asking. So I might ask people, that's just the beginning of scratching the surface. I'd get pretty deep on BGP. And they're intro-level BGP questions that I just asked. But they're very common questions. I usually ask people to tell me the BGP decision algorithm too. Hello, Mike. What if there's a CDN outage? Can it happen? Can it be a single point of failure? 1 is none, 2 is 1, and 3 is greater than 2. That's why I said use both. Exactly. And your DNS can do multi-value answers, weighted answers, etc., etc. Always build extra redundancy, because whatever you think is going to fail, I promise you, more of it will fail. All right, now we're going to talk about stuff that they call Azure Network Performance Optimizations. My definition of networking in there is a little bit different as a network architect. But let's do this. Can you guys give me an hashtag Azure Solution Architect Expert Training? Azure Solution Architect Expert Training. And if you're not a subscriber, please subscribe and hit the bell. Please hit the like button to tell other people what we're doing is beneficial. We put a lot of time and effort and money into free training. We really want as many people to see it as possible. Naga, in one of the previous questions asked about blocking traction, how do you block them? Well, you block them based upon a site or range, etc. Because you can tell their source address. You can tell there's lots of ways that you can do it. Source address or countries. By source address or by site or range, we typically know where people's IP addresses are coming from. I love it. Brian McCool, Azure Solution Architect Expert. Mr. Gee, Azure Solution Architect Expert Training. Ashwini, Azure Solution Architect. Alexandros, Azure Solution Architect Expert Training. AWS account, that's fine too. Azure Solution Architect Expert Training. DeJoy, Azure Solution Architect. Ron Miller, Azure Solution Architect Expert Training in Dallas. And Angelo, Azure Solution Architect Expert Training. This is music to my eye. I may be under the weather, but we're here. You guys are all giving me hashtags, Azure Solution Architect Expert Training, which means you're awake, alert, and oriented, which is really what I like to see and know. Even Leo's over there in Brazil. Thank you, Leo and Tracy. Please hit that like button. Tell other people what we're doing is beneficial. So let's talk about, and please make sure you register for that BGP and networking workshop. It's just critical stuff. Going to do it completely free for you next week. So let's talk about tuning the network, at least as much as we're going to be able to do here. Network optimization with regards to the cloud comprises the technologies and tools and things that we can maintain, improve, or maximize the performance. Now, there's lots of things we could do in the traditional network where I'd be talking about RSVP signaling and QoS and rate limiting and all kinds of cool stuff. We can't do any of that here. So there's limited network performance tuning we can do in the cloud. It's not like the data center. Now, when we tune our network, the IP addressing of our network is so critical. It's so critical that I'm going to dedicate 4 hours next week to teach you guys. Please sign up for the networking workshop where we're going to talk about IP addressing. The next one's going to be on BGP. And if we optimize our networking design properly, and something happens in one part of our network, it is less likely to affect another part of our network. So that gives us something called blast radius protection, where something happens in one place, we can limit to where it affects. We can talk about optimizing your data centers and availability zones to kind of protect from some failures. And we can really think about when do you need to go multi-cloud versus realizing that one single cloud is a single point of failure. When we start thinking about our WAN and our routing, when do we use static routing or routing? When do we use BGP? When do we use VPNs? We use VPNs when we need cheap, available, and quick connectivity. When do we use private lines or express routes? When we need guaranteed speed and performance. When do we use a BGP community so that we can match something and make a manipulative policy? This is part of it. Optimizing the network involves, not determining whether you can get away with, cloud basic firewalls, or whether you need to go to the marketplace, and you're generally going to have to buy, security firewall appliances from Cisco or Palo Alto, and how do you load balance across these virtual devices, etc. Looking at your security groups. So the first thing that's a network performance optimization we're going to talk about is what's called a proximity placement group. Let's think about this for a second. If I got some servers in Athens, Greece, I got some servers in Lagos, Nigeria, I got some servers in London, UK, I've got some servers in Palm Beach, Florida, and I've got some servers in Sao Paulo, Brazil right now. Now, the latency between these servers isn't going to be pretty. So if I had a high-performance computing environment and it's taking me 8 milliseconds for my traffic to get from point A to point B, I no longer have high performance. There are times where a nanosecond is a massive competitive advantage. I mean, massive. I want you to think of it in the financial world. Let's say we all want to buy stock in Apple, because we like Apple, right? This is not my financial opinion or not. Let's just say right now we all want to buy Apple. And for argument's sake, let's say the Apple price is $1. It's not, but let's just say it is. If there's good news out there that says Apple just made the new iPhone 26, and we believe it's going to sell $100 billion worth, guess what's going to happen? That stock price, everything's going to buy it in an auction, and the stock price is going to go sky high really fast. But what if we were the first people to buy that stock? We might buy that stock for $1 and a penny. The people that may buy it a minute later may buy it for $5. The people that buy it a quarter second later may pay $1.50. But if we can be the first or the fastest, we might be able to buy it for $1 and sell it for $5 a few minutes later, getting 500% return. Now, banks do these kind of things. So now think about it. Got my servers and structures all over the world. I just lost 8 milliseconds. I just went bankrupt in a bank. So most of these kind of high performance applications are going to have to stay in the data center for lots of reasons. But look at it this way. If you are able to get your financial feeds to the cloud, you can't do this for the multicast one, but you can for the unicast, and you could put all your servers real close to each other in the cloud. You could minimize everything. You can minimize the latency, which because you can maximize the profitability. So because of this, we're talking about proximity placement groups. So what is it? It is a logical grouping of your stuff real close to each other. And by putting your stuff real close to each other, the latency is less. What could it be like? It could be, literally speaking, putting all your virtual machines and servers in the same chassis or the same rack. And by doing it, what happens? You get reduced latency. Ooh, okay. I just put everything in the same rack. Excuse me, I'm going to go sneeze for a second. Apologies. Normally COVID doesn't make you sneeze, but that's probably coming from my beautiful cat Cindy. That's sweet and cute and cuddly. So apologies. Okay. So now you know what a proximity placement group is. It's literally putting your stuff all in the same rack or as close as possible to it. So we can do this with standalone virtual machines within an availability set, for example, virtual machines with multiple availability sets, and we can manage multiple different applications across hardware types. Best practices, when you're going to use proximity placement groups, and you don't always want to do this, deploy your virtual machine sizes in a template. Make them all look that good, and thank you for the bless you. And we want to include all of the application tiers in a single template so that they're going to be deployed at the same time. Remember, we want everything as close as possible in the same place. Ideally, we're going to put, for performance, the entire placement group in a single availability zone. Now, think about that. If we put our whole placement group in a single availability zone, look at this. When it goes across availability zones, you're going to have better availability. Single availability zone, data center goes down, you're in trouble. Multiple availability zones, you've got higher latency, but you've got higher availability. So this is going to be a decision that you guys have to make as part of your architecture. So for optimal resiliency, spell them out, spread it out. And you'll basically do spread VMs because a single proximity placement group cannot span zones. So just kind of keep about that and think about that in your own. So what's it look like? Let me show you architecturally what it looks like. Got this beautiful photo that Alonzo drew for me. It looks like as follows. We basically put our stuff in a very close together environment. And by putting it together in this very close together environment, what we find ourselves dealing with is low latency. Okay, we're going to get into security and identity and access management next, which gets pretty heavy. So let me do the following. Let's see if there were any networking questions before we get to this, and then we're going to get into security. I think I saw a networking question or two pop up in there. Yazid. Hi, Mr. Mike. Is BGP still used for 5G network? Of course it is. So I want you to understand, please go back to yesterday when we talked about the OSI model. No matter what with all networkings, we have layer 1, which basically includes the wired or wireless equivalent, the radio wave and wireless, versus the cable, the copper wiring, or the fiber optics. Then we have layer 2, which is the WAN technology that we're using, whether it be 3G, 4G, 5G, whether it be an Ethernet card, whether it be Wi-Fi. It's the layer 2 technology that we're dealing with, and that all stays the same. Yazid, at layer 3, we're dealing with IP addresses. And ultimately, we need to determine the path to get our traffic through the network. So we need a routing protocol, which is BGP. So whether it's 5G, it doesn't matter with WAN technology, all that is underneath the IP addressing scheme. So layer 1, think cable, radio frequency. Layer 2, MAC address, or whatever the Wi-Fi 5 is. Layer 3, IP address. And then you need a protocol to manage that layer 3, how to get through the network. And that is always going to be BGP for right now, unless we're dealing with software-defined networking. Good question, though. Okay, well, we're going to get into the security. So give me a hashtag cloud hired while we're at it. Cat hired. I love cat hired too. Totally works for me. My cat Cindy has a job. She's a troubleshooting coach. She paws off servers, chews through Ethernet cables. She's all kinds of cute. I'm good with cat hired or cloud hired, actually. I hired my cat. Beautiful little girl, by the way. That's why we do this whole thing. The whole plan is to get cloud hired. Otherwise, what's the point? Fantastic. Leonardo from Brazil all the way to, I think you said Germany. Sig Wolf, cloud hired. I'm loving that. Ashwini, cat hired or cloud hired. I'm good with both. Alexander, cat hired. F. Haristopoli. AJ, cloud hired. IT Pro, cloud hired. I'm loving it. And Charles, cloud hired. Travel with Benji, cloud hired. And AWS account, cloud hired. Cloud hired. And Sam J, cloud hired. Fantastic. Mr. Geek, cloud hired. Y'all, cloud hired. I've got to learn about that photo at some point, y'all. That's a pretty impressive one. Chris, cloud hired. And LM, cloud hired. By the name Souza, it's pretty obvious where you're from. And I keep thinking, I think you're in Germany. I think you're in Germany. Hawan's such a great guy over there in UK, cloud hired. So let's talk about security and identity and access management. Whenever we're with the cloud, we deal with these shared security models, which causes all this confusion, complexity, and all kinds of security events. What does it really mean? It means that security is shared between the cloud provider and the company. That's all it really means. So let's really put it into context. It means that you're responsible for your stuff and they're responsible for the infrastructure. Now, in this section, we've got lots of stuff to talk about. We're going to talk about principle of least privilege, otherwise known as need to know. We'll talk a little bit about industry compliance. We'll talk about shared security. We'll talk about some role-based access control. We'll talk about security tokens. We'll talk about a multiple account status. We'll talk about security groups and WAF. We'll talk about intrusion detection and prevention, distributed denial of service attacks, the Azure Service Catalog, and multi-factor authentication. We're going to get a little geeky on some of this. Azure security. Who's responsible? It's in between the customer and the cloud provider. Azure maintains the security of their cloud. And you, the customer, may maintain security of their VNet. So, two things are going on. Azure talks about securing the cloud. Secures their cloud. You secure your VNet. If the Azure cloud is hacked and they can't secure it, you are still able to get hacked, which is why the cloud is less secure than any private network in a data center. Because in your data center, you have to just secure your stuff. Here, you got to secure your stuff and hope that your cloud provider is secure enough to protect you. Now, who's the bigger high-value target? I've got a website, mycatcindy.com, or Azure. Of course, Azure. Now, that doesn't mean we shouldn't use cloud computing, but don't let anybody tell you cloud computing is more secure. It's got more attack vectors, and it's slightly less secure for a normal, modernized data center. Now, that doesn't mean that a 30-year-old data center with no security is as secure as a modern cloud. It's not. But a modern data center will always be more secure because of less attack vectors. So keep that in the back of your mind. Azure's been hit with multiple DDoS attacks, and they've survived better than anybody else, honestly. And we don't even know what's going on with lots of people. But Azure's honest enough to say they got hacked last year. So we can respect them dramatically. Every cloud gets hacked. Every cloud provider will get hacked. Every business gets hacked. It's just, every business that goes down, it's just a matter of when. So Azure does a pretty good job of this. So they maintain the security of their cloud. You maintain the security of your VNet. Azure manages their infrastructure. What's their infrastructure? Their routers, their switches, their load balancers, their firewalls, their IDS, IPS systems, their storage environment. Oh, wait. Now, what do you configure? Virtual stuff that sits on that same regular data center stuff. That's it. Same thing. So you're responsible for your data, your endpoints, your account, and your access management. So you're responsible for your networking, your information and your data, your servers and your containers, your storage, your accounts and identities, your remote access users, and your directory infrastructure. Now, who manages what in what context? Well, it depends on the business model you're dealing with. In an on-premise environment, like the kind I'm used to dealing with, this green screen really does not work well with the teal color. So on our on-premise environment, we do it all. But then again, when we're in control, we can make it better. In the infrastructure as a service environment, meaning virtual machines, et cetera, what are we dealing with? Pretty much, they manage the network, they manage their data center, and they manage their hosts. Now, in these platform as a service environment where most of everything is pretty much ready for you, I mean, realistically speaking, they're managing the data center, they're managing their network, they're managing the physical stuff, they're managing operating systems of their servers, and even a lot of the networking controls. And all you're really dealing with is your information and data. What about a software as a service application like Microsoft 365? Well, they're managing their data center, their network, their host, their operating system, their network controls, their applications. And basically, it's just you're getting your information, your data, your devices, and your accounts and identities, and pretty much everything else is managed by the cloud provider. So each one of these models gives you different levels of control. And with each different level of control, and different features and functions. All right, so we're now getting into this concept of identity and access management and who can do what. Now, everything we're going to talk about today is going to fall under the context of authentication, authorization, and accounting when we get into IAM, and we're not quite there yet. But I want to make it clear, what are we going to be dealing with today? Authentication, who are you? Authorization, what are you allowed to do? And accounting, what did you do? Keep that in the back of your mind. So one of the most important concepts in security is something called principle of least privilege. I hate that. I hate that term. It's too darn complicated. Here's another one I learned a long time ago. Need to know. If you need the access to the information to do your job, you'll get it. And if you don't, you won't have it. See, the military doesn't make things complicated. Need to know. The principle of least privilege means give people whatever access they need to do their job and nothing else. And the second they no longer work in that job, take the access away. Need to know. And that's going to get into role-based access control, which we'll be talking about heavily today. And I like calling a spade. I like making things simple, simple, and need to know. Now, when we deal with security, we're going to be dealing with frameworks and requirements and all this industrial compliance, all these big, super long documents we got to contend with, and we're going to get security audited with at the end of the year, and then we're going to have to prove to somebody over periodic. So just understand the cloud providers are understanding this, and they understand that as part of doing business, they all support the main standards, PCI for DSS, for example, HIPAA for U.S. healthcare, ISO 27001, ISO 27018, SOC 1, SOC 2, SOC 3, FedRAMP, HIP Trust, ENS FedRAMP, IRAP, and MTCS. Pretty much almost everything that you would ever need to deal with, et cetera, to kind of keep that in back. Hope that makes sense to you. So let's briefly talk about the Azure firewall. Azure has a firewall. It is a Azure-based firewall. And it's a technology that provides rule protection to provide like in a firewall. What do firewalls do? They keep unwanted traffic out, and they allow your traffic to go out, and it will return back. That's exactly what things do. So what is the Azure firewall? It's an Azure-based firewall. It's basically rules. Nothing allowed out is able to come in, and it can protect against some DDoS attacks, some SQL injection attacks, some scrape shifting. Azure firewall is a basic firewall offered by Microsoft. It is a Microsoft proprietary firewall, and it basically provides protection for web applications and web vulnerabilities. It's basically a web application firewall, and it protects against malicious bots, etc. What does it look like? I'll show you architecturally. So what you're dealing with over here is you've got your sites, and you've got this AWS WAF that you're deploying, ahead of your load balancers. What is this? This is a proprietary Azure firewall, which, guess what, means in a multi-cloud environment, you can't use it because it's proprietary. In a multi-cloud environment, which is 87% of your customers, you're going to need to go to the marketplace and get a firewall from Cisco, Palo Alto, Fortinet, or Juniper, or Checkpoint or something like that, which is going to work on all clouds. But this is the Azure proprietary firewall, and we're just talking about it because it's a certification thing. Generally speaking, in real life, I've never used one of these cloud proprietary firewalls. I always use a marketplace solution, but I just want you to understand that. That's one of the difference between working and actually passing a certification exam. So when we're dealing with this Azure Web Application Firewall, we're going to have two options. The standard option provides layer 3 to 7 filtering and threat intelligence feeds directly from Microsoft. So Microsoft is going to be telling the firewall about new rules. And it's going to tell it, when there's certain problematic IP addresses in the internet, which ones to block. So there's some good intelligence that's actually built into it. Again, there's nothing wrong with these firewalls. It's just that they're vendor proprietary in a multi-cloud environment. How are you going to architect that and actually make it work? So here's some more examples on how you can see it. You can see the Azure firewall is being used to protect the system. And this is your standard web application firewall. You're using it to protect your systems Basic firewall. Now, basic firewalls just do this. They allow your source traffic out. They don't allow return traffic in. And, you write a policy to allow what you want in. Now, the good news is the Azure Web Application Firewall has a premium option, which gets it closer to modern next-generation firewalls. And modern next-generation firewalls include intrusion detection and intrusion prevention, for example. Now, those kinds of things are in modern firewalls. Now, the Azure Firewall includes a signature-based IDP, which is, and we'll talk about the strengths and weaknesses of that in a minute. But realistically speaking, it's an IDS IPS system that looks for attacks based upon attack signatures, meaning you know what the attack is, it can block it. Now, these signature patterns include byte sequences, etc., that are known. Malware, Bitcoin mining, those kind of things, Trojan attacks. Here's the thing, this is signature-based. Signature-based recognizes an attack and blocks it. Here's what signature-based IDS, IPS systems don't do. They don't know how to stop attacks that they've never seen before. So what does that? Modern next-generation firewalls that you can get from the marketplace. What's so different about them? They use behavioral-based in addition to just signatures. And they can look at stuff that's not normal. What is behavior-based security? I can tell you right now. For those of you that are not architects, that are not used to jumping on 4 airplanes in a week, if you right now, let's say you lived in Palm Beach, Florida like me, if you went and flew to London and spent $10,000 on your credit card, and then went to Peru the next day and spent $1,500, and then went to Dubai the next day and spent $2,000, and then went to Cape Town, South Africa the next day, your credit card company, I promise you, is going to call you and shut your card off. They're going to say, I see unusual buying patterns and we don't expect this. Is this you? That is behavioral-based training. Now, by comparison, if you work for Cisco like I did, and you were in 3 countries in a week, guess what? The first couple of times the credit card companies called me and shut it down. And I said, I'm an executive. I travel to 3 countries a week. They monitored my account. They started looking that it was normal, and they never blocked me. And then I got sick, didn't travel for 3 months, and then they blocked it on the first time because they knew it wasn't my normal pattern of behavior. That's behavioral-based security. What we're talking about here is signature-based. But still, if you're dealing with a proprietary firewall, web application firewall, it's still pretty darn solid. It's just not ever going to be as good as people that do nothing other than security. Although Azure just invested a lot of money in security, and who knows, they might bring this up to speed and make it almost as good as the next generation firewalls. But here's the problem. Multi-cloud, can't use proprietary anything. Use the same firewalls across all 3 clouds. So let's look at the Azure firewall. It's basically providing, your IDS, IPS system, and it's looking at URL filtering. You don't want people to go to a certain website. You can keep certain web categories away, like the WebSense kind of thing we used to do. So it is a good solution. It really is. Don't get me wrong. I don't want you to think it's not a great solution. But if we need more robust, we can go to people that are the pure cloud security providers or the security providers like Cisco, Palo Alto, Fortinet, Checkpoint, etc., because that's all they do. Now let's talk about Azure Advanced Threat Protection. What is it? It's a threat protection solution that aids in the elimination of on-premise vulnerabilities to prevent attacks before they happen. It assists the security operations team to prioritize information and focus on the actual threats versus false signal, that kind of artifact kind of thing going on, and identify and resolve vulnerabilities and assess threats efficiently. You got lots of stuff and signals. You need to know what's real and what's not real. Let's talk about Azure DDoS Protection Standard. So what is this? It's a technology that defends against most DDoS type attacks. It provides some monitoring, logging, and alerting capacity. How does it work? It monitors actual application traffic, actual traffic utilization, comparing it to a policy or a threshold that you preset. If packets conform to the standards, meaning look right, they allow to be sent. If they're malformed, they're going to be blocked. You can rate limit packets. So for example, if I get 1 million requests coming to my web server from my cat Cindy, that's not good. It's going to take it down. So I can rate limit to a reasonable level of request if I needed to be sure that I'm not DDoS. And we can potentially examine the packets to try and catch packets or protect them before they're suited. So let's talk about what comes with it. We get some relatively good native platform integration. It's always on traffic monitoring. It gives us some adaptive tuning. It gives them some good attack analytics, some attack metrics, and it definitely gives us our attack alerting. It gives us a DDoS rapid attack response, and it gives us lots of mitigation. So, these DDoS protections that are offered by the cloud providers are very good. Then again, the DDoS mitigation that are offered by the content delivery network providers are also very good. Let's talk about Azure Servicer Trust Portal. What is it? That's a repository used to expose and provide customers with Azure compliance documentation, white papers, and reports, including documents like SSP that shows how Azure satisfies compliance requirements, etc. Service Trust Portal is where users reference to understand how Azure satisfies their compliance, because it's all about making sure the systems are compliant. Azure Service Trust Portal, what does it do? It provides access to compliance guides and audit reports. So if you need to know what you need to do for the ISO, it's there. For the service organization controls, it's there. For the National Institutes and Standards of Technology, the NIST framework, that security framework that we all use, that's theoretical in nature, it's there. FedRAMP, or the Federal Risk and Authorization Management Program, again, it's there. GDPR, or General Data Protection Regulation in Europe, that's there too. So it helps us maintain compliance with these standards. We don't get fined, so being compliant with the standards is good. Now let's talk about Azure Defender of the Cloud. This is a service that helps users prevent, detect, and respond to threats with increased visibility and control of the systems. Help you get access to your systems and fix them. That's it. Helps users protect resources across Azure, other clouds, and hand-on premises through its free and enhanced security capabilities. Free tier includes continuous assessment and security recommendations, because you got to know what's going on. Azure Defender of the Cloud, what does it do? It continually assesses your security posture so that users can track new security opportunities. Meaning, hey, wait, here's a cleanse to fix it. Here's something else to fix it. And it gives you a guidance. Defender of the Cloud recommends, makes recommendations on how to secure your workloads with step-by-step actions, for example. Again, remember, automated. So it could be good, could be bad, but at least it gives you something to look at first. Defender of the Cloud alerts defenders of user workloads in real time so they can react immediately and prevent security events from developing. Now we're dealing with this Azure Defender of the Cloud. We're going to have two options. We're going to have the Cloud Workload Protection Program and the Cloud Security Posture Management. Let's talk about the differences between them. The Cloud Workload Protection Platform continually assesses subscriptions and the organization for security issues and shows the user security posture and a secure score. They're giving a score of what's going on. It's an aggregated score of the security findings, something that at a glance will give you, hey, is it good or not good, based upon a number. Gives you some hardening guidance, which is good. Some visibility guidance, good. Remember, this is great, but it's automated, so it might be right, it might not be right. Your mileage may vary. Check it out 100% of the time. Now let's talk about the Cloud Security Posture Management Program. Here, Defender of the Cloud also offers security alerts that are powered by Microsoft Threat Intelligence. This includes a range of advanced intelligent protections for your workloads and the workload protections that are provided through Microsoft Defender plan specific type of resources. Okay, that's been about 20 minutes. Let's take about 10 minutes of questions. Can I give you an example of why I feel Akamai is a bit better than other projects such as Azure CDN? Well, Akamai's been in the CDN business for decades. That's all they do. And here's the thing. If you only do one thing and you're the market leader for decades, chances are you're better than the competition that tried to do a lot of things. Which is a better compass? $1,000 compass that's designed to use $1,000 GPS? Now, let's let you, which is a better GPS? A $20,000 GPS that gives me precision things, or the thing that's in your cell phone that's also designed to call people, watch YouTube videos and take photos? Same reason. So, and that's why Microsoft goes to Akamai and Verizon when they want better features and functionalities, because they offer something much better. That's the reason. Yazid, please small talk about zero trust security. Zero trust is a fantastic concept where nothing trusts anything. And that way, no routers are trusted, no switches are trusted, no servers are trusted, no people are trusted. And by constantly verifying who they are, it enhances security. Now, it's a great topic, that the kind of thing I would teach in my cloud architecture development program, because that's, realistically speaking, the future model for security, and it's very critical. But it's a whole thing. It's not just a one thing. It's a whole architecture. Chris, you can go to the next one. Can I explain how security access works for entities like device and human accounts and cloud resources? Naga, I need you to translate that for me. I have honestly no idea what you're asking me. I'm not trying to be difficult. I just have no idea what you're asking. Chris, let's go to the next one. Perhaps if he can write it in some more clear terms that I can understand. Now this is a question. Is zero trust implemented on Azure, and if not, why? So here's the thing. Zero trust is a philosophy and a connectivity option. And zero trust does lots of really cool things. Okay, can we boot the bot that's popping in some traffic? So when we talk about zero trust, what we're dealing with is as follows. This thing doesn't trust this thing, which doesn't trust this thing. Now, in our own systems, we know what we should be trusting or not trusting. And in our own environments, we can purely do zero trust. In the cloud environments, they don't necessarily know who's coming into what, where, and how. So they can implement some zero trust on their infrastructure, but not in other places. So they may or may not be zero trust. And even if they are, they can't do the complete zero trust the way you could do if you manage all the resources, because they don't have full control over who's using their systems. But all in all, these cloud providers have very secure, very robust systems. Very robust and very secure systems. Very. And whether they're using zero trust or not zero trust, they're still secure. So the key is zero trust is one type of an authentication and security model. Most organizations would benefit from zero trust. Most. There are lots of approaches to using zero trust. You can there's lots of ways that we could do it. And we can implement a zero trust security posture on Azure. We can implement a zero trust security posture on any cloud provider we want, or across clouds, because we, the user, are securing our systems according to a zero trust architectural framework, which is a way of doing things. So, for example, hope that makes sense. Hi, Mike. SaaS, PaaS, and OS, are they good ways of thinking in terms of separation when Azure supports? Brian, I hate the terms. I think they're worthless, useless, garbage terms, and I never use them. Why do I do them in certification boot camps? Because occasionally a cloud provider asks the customer. If I were to walk to a CEO and say, your platform as a service offering, they'd laugh me out of the room. I'd be fired and my replacement would thank me. They use these dumb terms in the cloud practitioner and basic terms, and they are marketing terms. Infrastructure as a service. You know why? It sounds a lot better than saying, here I'm your virtual data center. So they make up a term. Platform as a service. Okay, platform as a service. We do all this stuff for you. And all you have to worry about is this thing. Software as a service. We take care of everything for you. All right, seriously? Just tell me that I can pay for it in one spot. So I think these are really horrible ways of thinking. I basically think is, what's your customer want? Are they using Azure as a purely rented data center? And if they are, they get the most control, most flexibility, most scalability, best of everything. Or are they trying to make it easier on themselves and they're going to use fully managed services, which means reduce security, reduce control, reduce performance, but a lot less work? Or do we just want to use software that's pre-made and pre-hosted? So I don't really think in terms of that. I don't use marketing terms. I don't think in terms of marketing terms, Brian. I think in terms of what solves the customer problems the best, fastest, and cheapest way possible. That's all I think of. Are there any others in there, Chris? Authorization. Oh, Nagar, are you asking me about identity and access management? Because if you're asking me about identity and access management, we'll be talking about identity and access management very soon. Although I'm not sure that's what you're asking. I think that's what you're asking. In a public cloud, if a hacker got into an account, is there any threat issue for the other account holders? No. But if somebody hacks into the cloud, they get access to everything. So for example, when Azure's Cosmos database was hacked into like a year or two ago, like 3,500 customers' information was exposed. So if you hack the cloud, and yes, you get access to all the customers on the cloud. If you hack into my VNet or my VPC, well, then you only get access to mine. My database could not be stateless. I don't know why we're talking about databases. We're talking about networking today. You can go back to the database section from was it day one, and look at the database things. And I would love for you to go look at the database thing. Chris, did we have any others? Put up IO. IO has a very excellent explanation of zero trust. And IO is an exceptional security architect. And that's the key, is it's a framework, inside, outside, and it's determining who you are and making sure that you're allowed to do everything. So it's the way you build your architecture over a simple thing. IO, wow, such a nice, elegant description in those YouTube character box. That's why you are such an amazing cloud security architect. That crisp, that fast, I love it. Never trust, always verify. Exactly, IO. Exactly. And IO, please feel free to add any comments. IO's and security knowledge is off the charts. We love IO. I've had the privilege of working with him for a while. Mike, great training and explanation as always. Thank you, Angelo. Teaching the fundamentals so we're multi-cloud versed, especially when you're not feeling 100%. We appreciate this so much. Angelo, I love this community and working with all of you. Thank you so much. That sounds like microsegmentation. Microsegmentation is actually something different. Microsegmentation could be anything from segmenting your users in a VLAN so they can't talk to each other, or segmenting your network with multiple subnets and then determining your access control lists and your firewalls between them. So it's kind of a different philosophy. But the goal is the same. Protect, protect, protect. What happens in one location doesn't necessarily have to happen someplace else. Chris, are there any others? Okay, if there's not, we're going to get to service storage encryption. So everybody, please give me an Azure Solution Architect Expert hashtag. Hashtag Azure Solution Architect Expert Training, so that all of you know what you're hearing. Yazid, there are 10 different kinds of databases on Azure, and they are in the day 2. You can watch the full 3-hour video. Mr. Businessman, great session as always, Mike. Thank you so much. Brian, Azure Solution Architect, hand of God over there in England, Azure Solution Architect Expert Training. I'm loving this. Leonardo, Azure Solution Architect Expert Training. Leo Praties, Azure Solution Architect Expert Training. I love it. I love it. This is so good. Ashwini, Azure Solution Architect Expert Training. Ron Miller, Azure Solution Architect. And Alexandros, Efaristo, Azure Solution Architect Expert Training. And you, Angelo, as well. Mr. Businessman over there. Good to see you, Azure Solution Architect. And Robert Welch, great guy over there in Dallas, Texas, Azure Solution Architect Expert Training. And Azure Solution Architect Expert Training. I'm loving it. I'm seeing you all. Thank you for participating. And if you can, give us a like. Give us a comment. Give us a subscribe. Lots of people should be subscribing today. Let me see if you guys are subscribing. Show us a little love. All right. Almighty, good seeing you. Almighty, no longer the spaceship. Saeed, I'm so happy to see you. Azure Solution Architect Expert Training. Travel with Benji. Okay, so this is fun. You're all awake, alert, and oriented. And let's talk about storage service encryption. Simply put, it's just encrypting your data. That's it. It's going to protect the data to help support an organization's security needs. Typically, we're dealing with server-side encryption, meaning you stick your stuff on the server and it gets encrypted. That could be object storage, whatever the server. Now, we're dealing with AES 256-bit encryption / FIPS 140-2 compliance, and that's how we're going to encrypt and decrypt our data transparently. And by default, it's enabled for Azure Storage Account and can't be disabled. It's not like AWS where you start off unencrypted and then you enable the key management system to enable AES 256-bit encryption. This is by default. Now let's talk about an Azure Network Security Group. It's kind of like an access list security group kind of thing. What is it? It's a set of rules that you create to protect something that allows you to deny inbound traffic to and from an Azure resource. Access control, let's just think about it this way. For each rule, you specify a source and destination, port, and protocol. And on the EES, Cindy needs to get hired. She's the sweetest little thing. So let's talk about some Azure Network Security Groups. What do? They basically filter traffic like an access control list. Allow this traffic to reach this traffic, but not this traffic to reach this traffic. That's all we're talking about. So you specify your source address, your destination address, your protocol, TCP, UDP, ICMP, etc., and your port number. What does it look like? It looks just like this. So as you can see in this environment, what you see here is you've got the internet and you've got your NICs, your network interface cards, whatever you choose to call them, any term by that. And we are using the network security groups to protect these things. So granted, the internet should be behind a next generation firewall, which ideally should have an IDS IPS system behind it. And then after that, that's when we start getting into these network security groups, etc. Okay, so when somebody asked a few minutes ago about authorization, and I said we'd be talking about AAA, authentication, authorization, accounting, otherwise known in today's world as identity and access management. Seriously, who makes up these terms? Here's what we're talking about. Authentication, identifying you. Authorization, what can you do? And accounting, keeping track of it. So let's play. Authentication, identification of who you are or what you claim to be. Now, this could be a person or a system. It really doesn't matter. The first thing we need to do is authenticate too. So whether it's an iris scan, whether it's a fingerprint, whether it's a username and password, we're talking about identification of you. Mr. Gibbs, you're allowed in. Mr. Hacker, you are not out. Cindy the cat, you have access to everything. The cat that walks outside that scares my cat, you're not allowed in the house, even though you look like a nice cat. So there's that. Keep that in the back of your mind. So authentication can be a username and password. Some people like to call it auth, and I hate stupid abbreviations and made up words. I call it authentication. But if you ever see auth at the capital N in the end, you'll know what it is. The Microsoft Identity Platform uses something called OpenID Connect protocol for handling authentication. We'll get into Active Directory at some point. So now we're dealing with Azure AD authentication. Many of you know Active Directory is an identity and access management program from Microsoft that basically everybody uses to determine who users are, what they're allowed to do, and keep track of it. So they brought something similar to the cloud. This allows, self-service password resets, multi-factor authentication, and hybrid integration to write password changes back to an on-premises environment. This hybrid integration can enforce password controls back to the on-premises. And we can also do passwordless authentication, keys, etc. Now you know what authentication is, so let's get involved into authorization. What is it? Determining who and what you're allowed to do. So I'll give you two examples. Cindy the cat walks into my house. I see her. I authenticate her. Oh, that's my beautiful cat, Cindy. I open the door. She rubs her head against my leg and my foot for 30 seconds. Then she stares at me, and I cook her some shrimp. This pretty much happens every single day. I know. I'm a little bit beaten up or managed by my cat because I love her. And then when she's done that, she walks me over to a fishing roll, and I have to take a fishing call and move stuff around there. That's Cindy the cat. She's authorized. Now this scary gray furry Maine Coon that comes to the house that she doesn't like, she hisses when she sees her. That cat comes to the door and looks at me. And if Cindy's not home, I might put some tuna out because I think she's real cute. But when Cindy's home and Cindy's hissing and she comes to the house, I say, please leave. And when she doesn't do this, I basically throw some shrimp that I usually keep around in another direction, and she goes to eat the shrimp and she leaves my Cindy alone. But that's what I've done. So authorization. So authorization is what are you allowed to do? So different people are going to get different authorization privileges. How do you determine what they get? Need to know. What does the person need to do for their job? And that's all they should get and nothing else. So you may hear authorization referred to as auth capital Z. Again, I think this is a stupid way of looking at the world. Speak in full sentences. Do not use acronyms if you want to get hired, especially as an architect. Use complete words. But if you see it shortened as auth Z, now you'll know what it is. And the Microsoft Identity Platforms all use OAuth 2.0 protocols for handling authentication. Definitely cat alert time. Definitely cat alert time. Definitely cat alert time. Oh, well, she didn't come yesterday, so I don't know if I can figure out. I wanted to show. Well, Chris, maybe he'll do it later. Chris sent me a beautiful picture of his Sunny cat yesterday, which is quite cute. So let's keep going on it. And yes, it's the shrimp honeypot technique. I don't have it in me to scare the thing because I don't want to do that, and I want it to be happy, but I want it to leave my little girl alone. So now let's talk a little bit more about authorization and role-based access control. We can assign specific procedures based upon a role. Now let's talk about what are the roles. Well, whatever you want them to be fair. But let's just say this. Let's say you've got an executive that needs to access everything. You could create a group called executives and give them access to everything. You might have somebody else that needs access to something. So with role-based access control, what are we doing? We are limiting access to someone's job based upon exactly what they need to know. I hope that makes some sense to you. So each role will cover a set of permissions for a resource. And when each role is assigned to a user group, a service or principal, and we'll get through that, will have access to the resource. So allow the finance people to attach to the finance lab. Allow sysadmins to attach to everything, etc., etc., etc. Now, all these policies are now written in JSON, JavaScript object notation, and all the cloud providers are all using the same thing. So, what does it look like when you're dealing with this role-wise? It looks like something like this. Oh, good. I'm glad the color showed up. We determine what the person's role is. And our cloud engineers are going to write the policy based upon what we tell them in JSON that basically allow this, don't allow this, allow access to this, this, and this, but not this. Let's look a little more about authorization. Here you got a user. We've authenticated them and we know that this user is Jane and this user is Joey. Then we determine what are you allowed to access. We give them a token and then they can access what they need. So that's really what we're talking about, authorization. Like I said, auth-n is authentication, auth-z is authorization. Doesn't that look like the most confusing thing to try and remember in your entire life? I promise you're going to confuse lots of people, so don't use it. But I wanted you to be aware of it in case you see it. As we're talking about role-based access control, what's a role? A role is a group, something that you assign to a group of users to manage their identities. Azure roles. A role definition is a collection of permissions that we're going to be giving, such as read, write, delete, etc., etc. With Azure role-based access control, you have 120 built-in roles. So there's pretty much a role for almost anything you'd need without having to have your cloud engineer write a JSON policy for you. But if you wanted to, you can make them custom. There's a couple roles you should know about. Owner. Owner is like root, super user, king and queen, all together. Full access and full authority. Owner, root. Don't sign in with your root account. Hey, wait, with your Linux system, don't sign in as your root account because you can break stuff. Contributor has access to create and manage all types of Azure resources and new tenants, but cannot grant access to others. So you can see root can do everything. Contributor, which is pretty darn strong, has access to create and manage all types of Azure resources and tenants, but they can't grant access to others. So limit who needs access to be able to grant access to others. Let's talk about some other big ones. A reader. A reader can view Azure resources. That's it. Like, view them, but without accessing them. How about a user access administrator? They can manage an user access. So we can get very granular with the role. Now, when we're dealing with this, let's talk about Azure Active AD roles. They're basically roles used to manage Active Directory resources. So to determine who can edit, assign, etc., etc. So examples, creating and editing users, assigning administrative roles to others, resetting user passwords, managing user licensing, managing domains. That's the kind of stuff we're dealing with AD roles. Let's talk about three really critical ones. The global administrator, the user administrator, and the billing administrator. These are critical roles, pretty standard ones. The global administrator, this person is the person who signs up for the account. The Azure Active Directory tenant account, I should say, they become the global administrator. The main person who sets up the Azure Active Directory. This person manages access to all administrative features in Azure AD, as well as a service that is used to federate Azure Active Directory. So you can use this to federate to other systems. We'll talk about more of that later. This user can assign administrator roles to others, and they can reset the password for any user. So global administrator, the big person, they can manage this, sets up and manages the Azure Active Directory. Next, user administrator. Pretty important role too. Can create and manage all aspects of users and groups. They can manage support tickets, monitor service health, change password for users, help desk administrators, and others. Let's talk about a billing administrator. They can make purchases, manage subscriptions, for example, manage support tickets, and monitor service health. A little more about role-based access control. It's an approach to restricting systems access, as we mentioned, based upon the roles of users in the enterprise. Why are we doing it? To segregate duties. So, systems admins get this. Accounting gets access to this. Finance gets access to this. What's the point? What are we trying to grant access to? Need to know. If you need it for your job, you have access to it. And if you don't need to know, so don't give you access. That's what we're kind of talking about here. Let's talk about the concept of a security principle. A security principle is someone that defines the access policy and permissions for the user applications in the Azure AD tenant account. This security principle enables core features such as authentication of the user and application during sign-in and authorization during resource access. The security principle, this entity can request permission to access resources in the Azure Cloud, user, group, service, principal, or managed identity. Role-based access control, what's it going to look like? A little more into some graphics here. Role-based access control, basically you've got a user, you assign them a specific role, and they can access certain things but not others, and you're limiting who can talk to whom, etc., 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 based upon function. Talk a little bit more about role-based access control. Let's talk about a role definition. A role definition is going to list the actions that can be performed, such as read, write, delete. When we assign a role, we can further limit the actions by defining the scope of it. The scope is going to be specified to a management group, a subscription, a resource group, or a resource. Let's look, what am I talking about over here? We can we've got pretty granular in terms to our management group, our subscriptions, our resources, who can access what. I mean, this truthfully is, a way to really lock down our systems once somebody's already on the system. Let's look at it in another perspective. Here we've got our Azure Active Directory. We've got the root user who can create a management group and determine who can do what, anywhere, and why. Different roles will have different privileges. Let's talk a little bit about scope levels. And we've got a management group and a subscription with regards to Azure roles. Let's talk about the management group. The management group provide governance above subscriptions. You can essentially organize your subscriptions to the management groups, and the governance conditions will happen as you'll apply it, and then all the things in there will inherit the subscription. So you basically apply it to the group, and everything, subgroups, etc., will inherit the active associated subscriptions and roles. Let's talk about what is a subscription. An Azure subscription is a base container that comprises a group of related businesses or resources. The group of resources are usually used and built together. Let's talk about some scope levels. At the resource group level, We have a container that holds all the resources for the Azure solution. The resource group includes those resources that users want to manage as a group. The user decides which resources belong to a resource group and what makes the most sense to secure them. Let's talk lastly about a resource, and it's a manageable item that is available through Azure virtual machines, storage accounts, web apps, databases, virtual networks, and compute resources. All right, I know some of this IAM stuff is really ugly. Apologies, but we have to get through it. So kind of keep that in the back of your mind. Sometimes we just have to get through certain things like this. So let's talk about Azure AD. What is it? Azure AD is the Azure solution for identity and access management based upon Active Directory. It assists employees with accessing internal resources like the corporate network, etc., because it's an Active Directory. It is a multi-tenant, cloud-based directory straight from Microsoft. Azure AD combines core directory services, application access management, and identity protection into a single solution. It's Active Directory, everybody's been using it forever. Assists with employees accessing external resources, the Azure portal, and thousands of SaaS applications, and that's totally fine. Azure AD stores information about objects on the network, makes the information easy to find for system administrators and users. Security is basically integrated into the system through authentication and authorization and access control to objects. And Active Directory includes a set of rules, basically a schema, that defines classes of objects within the container and their security. Azure AD uses a structured data structure. A structured data store is the basis for its logical hierarchy. And it contains a global catalog containing information about every object in the directory. And of course, it includes a query and index mechanism. Objects and their properties can be published and found by network users and distributors, and it distributes data evenly across the network. Basically, what should you do? I would suggest build an Active Directory server and really learn Active Directory, and then this stuff is going to become silly easy to do. So who uses Azure AD? IT admins, the junior people that configure the stuff, the app developers, which are software developers, the Microsoft 365, Office 365, Azure Dynamics, who's going to use it. Our cloud engineers, they're going to be using the system, are going to be using it. DevOps engineers are going to be using it. Pretty much everybody that's going to be using our system will be setting this kind of stuff up. What features work in Azure AD? Well, basically speaking, everything you would normally need to do with Azure: application management, authentication, Active Directory, business to business, business to consumers, conditional access, device management, domain services, enterprise users, hybrid identity, identity governance, identity protection, managed identities. Same Active Directory stuff. And I'm sorry, this stuff gets pretty ugly. But Azure enables something called seamless sign-on. What is seamless sign-on? It is a service that automatically signs in users to the users so basically, they sign in at the corporate network. They don't have to type in usernames or passwords. It's going to provide users easy access to cloud-based applications without additional on-premise components. It provides enhanced user experiences. It's relatively easy to deploy, and seamless sign-on is not applicable when you're dealing with Active Directory federation. So kind of keep that in the back of your mind. Let's talk about some seamless sign-on benefits, and then I'll get to some questions. I see they're popping up. Benefits include a great user experience. Users are automatically signed into both on-premise and cloud at the same time because it's their own systems. And you don't keep needing to enter the same password, which is good. Azure Seamless Sign-On is easy to deploy and administer. There's no additional components required for on-premises for it to work. It works with any method of cloud authentication, password hash synchronization or pass-through authentication, for those of you guys that know that from their Windows days, and the ability to roll out with some or all of your users via group policy. And of course, you can register Windows 10 devices into Azure AD and AD file system infrastructure, et cetera, et cetera. How does it work? Well, The Azure Seamless Sign-On service is a service that, let's go about it. How does it work? What happens is an Azure account is created. And it's this weird Azure account, Azure Read SSO ACC. It's created on your AD Active Premises Directory service. I'll actually pop up what it actually looks like in the chat box so you guys can see it. It creates this very, very weird access account called that. It's in your on-premise Active Directory. In each Active Directory forest that gets synchronized with Azure Active Directory. Additionally, several Kerberos service principal names are created and that are also used during the sign-on process. And the computer's account's Kerberos decryption key is then shared securely with Azure AD. For multiple AD forests, each computer account will have its own unique Kerberos own decryption key. And what's seamless sign-on going to look like? I'm going to show you right here in this beautiful picture that Alonzo drew to try and make some of these challenging concepts look a little easier. So as you can see, what's going on as follows. You've got a user, they log into Azure Active Directory. And from there, they're getting authenticated to the systems, and then they can access everything. One time, one sign-on, in a very simple and elegant sort of way. Let's briefly discuss the difference between seamless sign-on and single sign-on. Then we'll take some questions because this stuff I think is pretty ugly. But then again, I'm a enterprise architect and network architect who's also a cloud architect, but I am no IAM architect. So for me, this IAM stuff, and this is more like sysadmin stuff, it's not my world. So let's just at least talk about it a little bit. Here's the difference between single sign-on and seamless sign-on. Single sign-on is an authentication method that lets you sign on once with a username and password and get access to multiple systems. Seamless sign-on, by comparison, occurs when a user is automatically connected to their internal connected applications on the network, and they're just allowed access to everything else. So that's basically the main difference between the two. So Chris, it looks like there's some questions. Let's try and take the questions. And please ask some questions if you have some. If 1,000 users want to connect to the Azure virtual desktop from the office, is ExpressRoute recommended than the internet? Well, in today's world, I don't really see why 1,000 users would even use a virtual desktop, and here's the reason why. The virtual desktop costs what it would cost per month, costs in about 4 to 5 months, costs what it would take to buy someone their own notebook computer. So I'm not sure why people would actually be using a virtual desktop. But if they did, it depended upon the performance they would need. And if they were using that and they needed good performance, yeah, they'd need a direct connection or a private line like ExpressRoute. But here's the thing. First, I'm hard-pressed to find an example where somebody would need a virtual desktop in today's world. Now, there are certain financial institutions where people use Citrix and virtual desktops because they want a remote access from home and they don't want to leave the data leaving the building. So there are use cases for it. But as a rule, I'd be asking people why I was doing a virtual desktop in the first place just to make sure that it made sense. Generally speaking, you're going to use an ExpressRoute connection because it matters. You've got one data center that needs to connect to a data center, and a millisecond of additional latency can cost money. That's generally speaking when you're using ExpressRoute, when you need guaranteed performance. If by comparison, I've got, I'm streaming real-time video data from the source in a movie studio in California to some other place where it's going to be tuned and done in real time, and I want broadcast quality TV, and I don't want a single packet that's lost, I'm going to use a direct connection or an ExpressRoute or a private line. But if it's simple stuff that's not critical, I'm going to use the VPN. So the key is a virtual desktop critical? First, why is somebody even using a virtual desktop in the first place? Questionable. Then secondly, assuming they are using a virtual desktop, what performance did they need? Can they tolerate the latency of the internet or can they not? The key point of virtual desktops is that they are very tolerant of latency and low connectivity speed. So you might actually not need it. So the key is, what's the internet performance like? Where are you using it? What's the packet loss like? And what's the latency, which would then determine. But I'd first ask you, what are you trying to achieve with 1,000 virtual desktops? And why? Given the cost versus the actual ability to basically get somebody set up with a $400 notebook computer, as opposed to paying $60 to $80 a month for a virtual desktop. And after 6 months, you've got a problem. You're still paying for it where you wouldn't be paying for the notebook. And then you're even paying to use the networking and the bandwidth on your virtual desktops every time you actually use it. So it doesn't feel like a cost-effective business relevant solution for most cases, except in rare occasions where you've got bankers that don't want their stuff leaving the bank and they're using it remote access from home. What's the next question? What are some best practices for managing usernames and passwords in the owner accounts? So where should that be stored and backed up? There's typically a secrets manager that everybody has that you can use. Or if you're going to back stuff up like that, back it up in a secure, encrypted environment. And then, Angela, you start getting into the question of online versus offline. So if I've got something really critical and it's some device that's sitting in a safe that's not connected to the internet, it's not hackable. Now, granted, they can send a bunch of attackers to break into your systems and use a blowtorch to cut through your safe, but it's more secure than if it's online. So realistically speaking, limit who you give access to. Make sure that the people that are creating these accounts need to be creating them and when they're doing them. And generally speaking, people keep their systems in, say, Active Directory or something like that. But, and this stuff is all encrypted and when it's stored. So the key, realistically speaking, is how do you set this up so people can't get access to your systems? Who needs to access the Active Directory server? I'll tell you one thing. If you can limit that to an IP address or a subnet, filter everything else out and only allow that administration to a single subnet. Firewall it off, network security group it off, lock it down. So even that could be a way just to lock it down. The key is what you're managing, how many you're storing, etc. And Angela, I am not the world's greatest IAM person. I actually know this really great IAM architect, Isaac, who this is all he's done for decades. But username and password, the owner account, I would make sure that if I was going to use one and it was mine, it'd be super secure. It'd be this long. And I'd store it personally for me on a key, on a safe inside of a safe. And I'd make sure that I had some very good physical security in that building. That's how I store stuff that matters in the owner account. But I'm a little paranoid, but I don't get hacked that way. Great question. Chris, let's go to the next one. What are best practices against when to use versus assign individual permissions? Excellent. This is a really great question. Let me explain Angela's question. So I could create a user named Angelo. Now let's assume Angelo has some really good knowledge on applications. Let's assume Angelo has some really good knowledge on cloud. Let's assume that Angelo is a great guy and he's got lots of business acumen. I have no idea who Angelo is, but by the questions he's asking, these are really smart questions, and I got a feeling he's got a good background. So there's that. Now, if Angelo is part of my company, I'm going to hire somebody like an Angelo, and I'm going to say, Angelo really is part of this group, but, what about this? I want him to do all the stuff that's not part of the group. Then I might make an individual permissions just for Angelo. By comparison, I have no idea what your background is, Angela, but let's say you are an application developer, an application architect. Again, I have no idea. I would limit your permissions to whatever an application developer or an application architect would need to know. And then I would just assign you to the group of application architects. But if there's something special about you, I might create special permissions for you. So if I had a 6-man SEAL platoon, I'd probably give them different access than I would give to 4 really great E5s or E7s from the Navy, just because they might need access to different things to do their job. So that's what I'm really referring to. If you're going to do something that's out of the scalability, and use groups anytime you can. Because could you imagine having 200,000 employees and making 200,000 policies? But sometimes you bring in a consultant and they need access to a lot. Or sometimes you have a special employee that's so much better than the rest and you want them to have access to a lot. That's when I would use individual permissions. Excellent, excellent, excellent question. You always come up with some great questions. Naga, again, I generally don't understand your questions. So again, I'm not trying to be too difficult. If you're asking me how I would set up an entire Active Directory structure and where all the users' accounts would go, that would be a multi-hour conversation. And again, I'm still not Mr. AD. But how are these set up? They're set up very simply. There's a simple menu, and it's pretty easy to do, and it's pretty self-explanatory. But what happens if you use Active Directory? So 1 is none, 2 is 1, and 3 is greater than 2. Don't ever have a single Active Directory file. Have multiple, and have it highly available, highly redundant in 3 clouds. And you won't be losing Active Directory. 2 clouds, a data center on a cloud. You won't be running into this problem. You never use 1. Because Yazid, if you just use 1 and you lose it, you don't have access to anything. So protect yourself. Use more than 1 Active Directory. Here's kind of these very interesting questions. Single sign-on, seamless sign-on, and then we don't want to ever trust anything. I'm not really sure how all these calls are getting through. I have my phone set to not ring on focus mode, or at least that's what I thought I had it on, and they managed to be getting through anyway. So I don't think they're necessarily the same, Angelo, and necessarily. So zero trust is nothing trust anything. So let's think about how that would play out. When we use seamless sign-on, and I would always love your perspective here as well, but when we use seamless sign-on, what's going on is we're signing on to 1, and then we're getting a token for everything else that we're accessing. So we're getting a verification token, a one-time token, to prove that we have access to the systems. So it's not like we're not doing any further authentication. It's that the authentication is only happening 1 time on the user side. And then we're getting something that's used to authenticate to something else, which is then going to get another token to authenticate with something else. So kind of keep that in the back of your mind. And like I would say, kind of keep that in the back of your mind. So it's not necessarily that they're different, but think about zero trust. Your router doesn't trust a switch. Your this doesn't trust a user. Your this doesn't trust this. Your this doesn't trust this. It's much stronger. Zero trust to me is all based on IAM, which is good. To me, IAM still the last level of defense, because if they can't get past my firewalls, my IDS, IPS systems, my access control lists, and my security groups, they're not even hitting my identity and access management system. So to me, that's the last line of defense. But now that we're getting into zero trust and we're using that to authenticate everything, it's getting much better. And IAM is becoming pretty significant. And as we get to the cloud, We can do less network security, etc. This whole IAM thing and zero trust becomes really great. But again, Io, I would also say if you've got any comments here on the zero trust, please feel free to do so. Angela, I love these questions you keep coming with. Angela, you would suggest user groups role-based and apply access control permissions to the user group. If you remove a user from the group, the user loses all permissions for well. Yeah, that scales so much better. So much better. Class Active Directory systems were designed to work and without load balancers from decades ago. They have their own ways. They build their own forests, etc. They communicate with each other. So we don't need load balancers for them in much the same way we would normally for regular servers. It's a clustering protocol they've been using for decades because the assumption is you always are going to need more than one. Great thinking, though, Klaus. Okay, so there's no more right now. So what we're going to do, we're going to do a little bit more, and then we'll finish it up for the day. You guys will all get a good weekend. I'll catch a little rest, and we'll finish on Monday. So while we're at it, give me a hashtag Azure Solution Architect Expert Training. That way I know you're here. And I know, excuse me, that last section was really ugly and complicated, so bear with me. Let's talk about an Azure AD Federation. What is it? It's a collection of domains that have trust. Okay, so domain 1, trust domain 2. We have a federation, a term that's been around for a long time. So it usually involves having established trust and established trust. Now, levels of trust may vary. I may say, I know Io real well, so I may trust Io completely. I may not know Angelo, so I may not trust him. And those kind of things. So, there's that. But what's going on is it's a method of authentication and mostly includes authorization. So federated identity is 2 connections. And when we're dealing with AD federations, we're typically talking about another Azure AD systems. We're doing this, it's optimized for high availability, scalability, cross-geography redundancy, as well as ease of management. So when we're dealing with Azure Identity and Access Management, treat identity is basically the security perimeter. Centralize your identity management in a way that you can manage it from a single place. Enable single sign-on. And here's why. If your users sign on once, and they don't have to have 1,000 passwords, your users don't put sticky notes on their computer with all their passwords. And trust me, if you implement too many passwords and they're too complicated, your users will have sticky notes on their desk with their passwords. You don't want that. So you want to basically you want to enforce multi-factor authentication whenever you can. Because steal my password, which you will, but not have my authentication device and my authentication key, pretty hard to get into my systems. We want to lower exposure of the privileged accounts. We want to control locations where our resources are located. We want to plan for routine security improvements, and we want to enable password management, all from one place. So getting into this question that Angelo asked before, which was a brilliant question, he's got to be a super sharp guy. And when he was talking about, zero trust, and does it really work against what we're talking about? So what's going on is we're dealing with security tokens, which allow client applications to access a protected server. A token is going to be issued by an authentication server. A token is a one-time password, effectively, a one-time authentication device. The token is going to contain information about the user and the resource for which the token is intended. A centralized identity provider is going to be really useful here because it's going to look and, so the centralized identity provider is going to be helpful for applications that have users located around the globe who don't necessarily sign in from the internal network. If you've got an identity provider that centralizes one place for them all to do it, Security tokens allow a client application to access protected resources on a resource server. What's a resource server? Something that serves something. Now, when we deal with tokens in Azure, we're dealing with three kinds of tokens. We are dealing with access tokens, ID tokens, refresh tokens. So let's talk about what these tokens actually are. So access tokens are, what do they do? An application receives an access token after it authenticates and authorizes and then passes the access token credential to the target API. Accessing systems, right? So there's that. An access token will identify a user, app, or page and make graph API calls with a string. When calling a resource server, the access token must be present in the HTTP request. An access token is denoted access tokens in the premises respond from Azure AD and business to consumer. The application receives an access token after its user successfully authenticates and gets authorized access, and then passes the access token as a credential to the target API. Now that's for access. So what's an ID token? This is a token that proves that a user has been authenticated. Okay. It's used in token-based authentication to cache user profile information and provide it to the client application, thereby providing better performance and experience. ID tokens should never be used to obtain direct access to APIs or make authorization decisions. A little bit more about what do these ID tokens do? These tokens are sent to the client application as part of the OpenID Connect flow. ID tokens can be sent alongside or instead of an access token, and ID tokens can be used by a client to authenticate the user. Let's talk about refresh tokens. What are they? A refresh token is used to obtain additional access token. This allows you to have short-lived credentials without having to collect credentials every time one expires. The main purpose of a refresh token is to considerably shorten the life of the access token. What do the refresh tokens do? The refresh token is used to obtain new access / refresh token pairs when the access token expires. Refresh tokens are also used to acquire extra access tokens for their other resources. The refresh token can then later be used to authenticate the user when needed. So now you know what the refresh tokens are used for. Let's briefly touch Azure AD OAuth 2.0. What is it? OAuth is an open standard authorization protocol framework. And it's basically a means to connect to these Azure resources. OAuth doesn't share password data, but instead it uses authorization tokens to provide identity between consumers and service providers. OAuth is an authentication protocol that enables you to approve one application interacting with another, whether on your behalf or giving it away. Architecturally, what does this look like, or the way the pieces and parts get put together? As you can see, you've got a user that's going to open their web browser, and then they're going to hit their web app. From there, they're going to get redirected to Azure AD for authentication. There, the user is going to enter their credentials, and they're going to get a token, an access token and a refresh token. They'll then be redirected to the token app, which will validate their token. And after the token's validated, they'll get sent to whatever resource they wanted. So like I said, it's pretty ugly when we talk about it, but when you look at it realistically speaking, you get your you open your browser, you go to the web app, and you hit, okay, I want to do something. So you get sent to the authentication server. Then it queries you, it hits you, enter your credentials. And then you give them your credentials and you get a token. Now then you get your token authenticated, and then you get access to the system. So it's a pretty intelligent way of doing things if you really think about it. It just sounds horrible when we try and describe it. You just see where we're at, so I know where to. So let's briefly, actually, you know what? I think here's a good place to stop. I'm going to stop here and then open it up for some questions. So we've got about 15 minutes left. Let's open it up for some questions for the day. You guys all having a good time with all this Azure training? I know it's a little dry when we start talking about identity and access management solutions. I'm starting to look through the audience here, and I see where some of you are coming. Loving it here. I'm so happy to hear that, IT Pro. I assume Mufaz, I'm pretty sure he's in Nigeria. I love that. Tell me where you're all from while we wait for you guys to ask some questions. Ron Miller, wonderful. I'm so happy to hear this. I know it's fun talking about the networking, and I know it's fun talking about the compute, but let me tell you, identity and access management for me was never fun, so I hope you guys are doing great with it because it's a critical part of the certification exam. And God, it's so wonderful to see you here. And Chow is obviously, look at that nice little smile. She's always got a way to make all the rest of us happier here. It is down there in Brazil with that Azure Solution Architect expert training. Leo's super capable and super smart. Brian's over there in Philly. Boy, that's a place I spent a lot of time in. Lots of years in Temple Universities. Thank you so much, Hand of God. I'm so grateful for your nice statements there. Lonzo Coleman, you're loving it. That's fantastic. I appreciate this. Io, very good training as usual. Thanks, Mike and team. Fantastic. Being a little under the weather, I wanted to do the best I could for you guys. Good session, Arshad, IT Pro. That's fantastic. I'd be very curious to ask what's going on with those remote desktops. Unless you're in the banking world, in which case I totally get it. Sorry, I'm looking at the wrong screen. I may not be able to see the questions that are coming from my team. Io, very good training as usual. Thanks, Mike and team. Thank you so much, Io. Tracy May, good session as always. I think that's fantastic. Derek, first time joining. Your great job so far. You're loving it. Fantastic. Please go back and see the first few days. They were much more fun, but I'm thrilled you're here. I want to get you guys all certified, knowledgeable, on your way to getting hired and whatever it takes to help you build your best career. Sharon J, thanks, Mike and team. Floss, an excellent session as always. We love that. Leonardo, thank you very much, Mike and team. AWS account, great session. Why, great, it's wonderful. Take rest and get well soon. I promise I'm going to be resting all weekend. Wishing me a happy weekend. Thank you so much. Angela, Mike, you're the best. Thank you. Angela, I love these questions. I'm so thrilled you're present here. David, thank you. Thank you for being here. So, all of you, if you can give me a hashtag Azure Solution Architect Expert Training and a hashtag Cloud Hired. You know I'm obsessed with getting everybody hired, so kind of help me with that. With that, I can see it in the background. It makes me super happy. Yazid, thank you so much for our excellent sessions. Thank you for being here, Yazid. Thrilled that you were here. Tracy May, Azure Solution Architect Expert. Brian Training, cool. Azure Solution Architect Expert Training and Cloud Hired from you and Joe H. Tracy May, Cloud Hired. Yep, that's the whole point. See, I love this. Alexandros, fantastic. Charles Finney, Leonardo Souza, Leo Cloud Hired. I would love it. I love it. I love it. Thank you for another wonderful session. Thank you for being here. We're going to carry over this on Monday. We will finish it on Monday. We'll have a great time on Monday. A determination, child, that's really something that really matters with everything. So do what you love. I love teaching people. Russ DJ, thank you so much. So it's such a wonderful to see how many of you have been from all over the world, have joined us. I really like this. Can we bring in the one from Hand to God? I really like this philosophy. The Go Cloud Architects team is so great. I think you can all start an army of your own to rival any art there. Thanks to you, including Cindy. Mental toughness is pretty important. I've done a lifetime of martial arts, etc. A lot of my team has a very strong background of from the tactical community, etc., etc. Thank you so much. I love to be called teacher, Naga. The discount is on until Saturday, so please take advantage of it. The coupon code is potential. Oh, I'm sorry, it's on until Sunday. Even better, my team knows better than me. I just teach and get people hired. My team takes care of all those things. Can you give an insight into local versus Active Directory authentication and when to stay with local? So I don't really think it matters, Joe. Let's try and think about it this way. If I have an Active Directory server and it's in Japan, and I have an IP connection to that Active Directory server in Japan, I can authenticate to it. Now I can stick my Active Directory server in Azure, Google, or AWS if I'm managing and running my own Active Directory server, and guess what? It's still going to work. So the real key is, where do you want to authenticate to? Quite frankly, I would authenticate locally in my data center because it wouldn't have to go over the WAN for latency purposes, and I'd have an Active Directory server in every other cloud. And that way, here's the thing, it would just, it would work no matter where I'm at. So I would have my own Active Directory server, not use any of these cloud-based directory things. And then I would federate my Active Directory servers directly to each cloud-based thing. So federated to the AWS IAM system, the Azure AD system. And that way, all I'm doing is managing my own Active Directory systems everywhere on multiple clouds, anywhere at the same time. So it really doesn't matter where it's at. So it doesn't make a difference, as long as you have IP connectivity to it. And that's what most people don't realize. If your networking is in, it doesn't matter where your stuff is, as long as you can reach. Now, the network speed will be a big determination. The latency of how long it takes for you to get there will matter. But I would go local when I can because the latency is less. Why is the latency less? The latency on my LAN is 0, like a millisecond or less. The latency on my WAN might be 5 milliseconds, so it's going to slow it down a little bit. But I'd have one on my LAN and one per cloud. I don't design systems where I expect everything to fail. And I also don't like to use too many cloud services whenever possible. I like to use the main systems and use the cloud as my virtualized data centers. And that way, they raise my rates. I go to another cloud. Who cares? I want to move it from one cloud to another cloud. It doesn't matter, and I can do it in a moment's notice. But I come from a world where agility, speed, and freedom, and the ability not to be vendor locked in, and to be agile and change a business on a dime is really critical. So I come from the world from a slightly different perspective. So I overbuild everything. Because I've learned from my 25 years of architecture experience, when you don't, it falls apart. Everything breaks at scale, and nobody ever expects it to get that big, but it usually does. Kabinga, Azure Solution Architect Expert Training. Where are you located today? Love the name. I've got some theories, but based upon your name, but you never know. Any last questions before we have a really fun weekend, everybody? So please, we talk concepts. You want to get hands-on, download those Azure Student Access Labs. Benedict, you said you finally signed up today. Oh, I hope to see you in class. I haven't been monitoring who's actually had a chance to sign up or not. I'm sure my team is doing it for me, but we are thrilled to have you in the program. And I can't wait to work with you and meet you in class. Assuming you sign up for the live one and I get to meet you. You have a question, cool dude? Let's answer your question. Actually, cool dude, what I said is that where you locate your servers will determine what the latency is. So if I have a Microsoft Active Directory server in my house, it's going to have less latency than if I have my Active Directory server in Reading, UK. I can still use that Active Directory server in Reading, UK. And I used to go to Reading, UK, right next to the Majestic Stadium almost every week. And I loved it there. It was a great place. But the point is, you know, if it's local to you, you'll have much lower latency. Milliseconds of latency. Great question. Any other questions? Okay. Well, if there's not, have a wonderful, wonderful, wonderful weekend, everyone. Try and go back, go through some of the content this week. If you've got questions after that, we'd love to answer them. Get some rest. On Monday, we've got something. Next week, we've got the 2 Azure networking days. I know we're going to do BGP for 4 hours one day, which is really critical. We're going to do some IP subnetting and supernetting another day. And this is going to be some fun stuff. These aren't Azure networking days. These are real networking days. This is stuff that's going to help you regardless of what cloud you want to work with. It's going to help you build your career. It's critical, critical stuff. So spend that time over the weekend. If you'd like to do our training, we have 30% off right now until Sunday using coupon code POTENTIAL. And make sure that you download or you sign up for access to our Azure Lab demos to get some hands-on experience with this, because I want you getting some experience, but I wanted to focus on how stuff works and why it works to give you more of the career things. So have a wonderful, wonderful weekend. Please register for the BGP workshops, and who knows, we may have some AWS news for you coming soon too. So sign up, hit the bell so you get informed of new things. If you're a subscriber and you hit the bell, you're going to learn new things. Have a wonderful weekend, everybody.